Hello, good morning, everyone. So Harshal joined. Am I audible? Hello. Um, okay. Hey, thanks, Shabi. Good morning. Thanks for the confirmation. Hey, thanks, Sachin. Okay. Let me share my screen. I'll just need a confirmation whether is my screen also visible now. I've just opened the GCP console. Oh, okay, perfect. Yeah. Thanks for the confirmation. So I hope you guys are doing good. I see a couple of other folks as well. Hey, good morning, Dinanath. So, how about practicing the practicals or the demos or the walkthroughs that we have discussed so far? Has anybody tried? Any issues anybody has come across? Anyone? Yes, I tried and it has worked. Okay, good to know, Shiva. So let me know if you guys face any issues. Sometimes might happen that we keep on creating VMs and all those things in let's say in any specific region or something like that, right? So then I tend to stick to one region because it should be I should be either able to reuse it in some other way or the other in one of from one demo to another demo like that, or it should be easy and straightforward to understand also. That's why I stick to some plan, similar plan, similar VMs and configurations. But what happens is sometimes Google randomly gives an error about the quota resource quota in that particular region for the free tier accounts. So if you face that kind of issues, just select another region and try it out in that one. So I have seen that one, but good that it worked for you. Sachin says last week I have tried and it haven't tried, was traveling whole week. Okay, no issues. Meanwhile, let me do the speed test. But Sachin, do try it. Okay. So whatever we learn, I would say just go ahead and try whenever you get time. It's in a way it is good also to have a weekly classes so that you get 5 days of time to try out some of the things. We'll wait for one more minute. We have pretty extensive. mm we are going to conclude the networking part today. So I'm just going to wait for one more minute for people to join and then we'll get started. Shabby in progress, no issues so far. Okay, perfect. One question: when I ping to other VM and I'm getting continuous logs as 64 bytes from, is that expected? Yes. So if you are pinging on the external VM, let's say from one VM to another, if you are getting 64 bytes and then when you once you stop that, if you do a control C, so it will stop sending that message. So if you should see whether all the packets went or was there any packet loss. So if it is 100% delivery, then that means those are reachable to each other. If you are using external, then ideally they should be reachable, right? So that's what we have seen. But in the real case, like will not be using with external IPs in your projects. So with an internal IP, we have different demos we have seen, right? With an internal IP, they should be reachable, depending upon what demo we work upon. Okay, I tried VPN. You mean VPC session practical? It works for me. Okay, perfect. Okay, so now for today's session, we'll be focusing upon the load balancing. Okay, so these are all the topics that I'm going to touch upon. Even I'm going to do a demo on one of the load balancer, a rest of the load balancer, and this will be a extensive around 1 hour will be on that. Load balancer from scratch we'll be doing. Which will include the demo for the above two as well. But the above two topics are VM related, okay, compute engine or virtual machine related. But I'm going to cover them in this particular session because these are basically required for the load balancer. Those are the building blocks for the load balancer. That's why I have reserved them for this discussion. Other than that, we have other types of load balancer, which I'm going to walk you through the architecture of them. Okay, and then at the last, we'll see when to choose what load balancers, right? So then let's get started. First of all, we'll talk about what is load balancer, why do we need load balancer. Okay, some simple layman term. If you do not have any background of what is load balancers, then that is also I'm going to cover. So without a further ado, I think let's get started because we have a long path to go. Okay, so let me say load balancer. Okay, okay. So in simple words, in a layman term, what is load balancer, right? So as the name suggests itself, right? It is to balance or distribute the load of your computation or whatever traffic requests, whatever I can say anything here, right? Whatever the request or the traffic comes in your environment, if you want to distribute that, okay, to have, let's say, fair, not fair, but a balanced, okay, performance, to have balanced performance, right? Reduce latency, let's say. So these are some of the I'm just putting in a simple words so that what happens, what are the advantages? We get a balanced performance, we get reduced latency, means speed, response, lesser response time, let's say, you can say, right? So the faster response. So something like that you will get with the load balancer, right? So if you just try to this is for those who do not know what is load balancer. So you must have seen, right, in your project. I'm just taking you to your project's hierarchy, right? So you must have worked upon in the projects, right? So let's say there are a couple of stakeholders in your project, right? Or we call it as business or clients, right? Then what happens is they deliver some work to your company, and this is your company, right? Okay, and within your company there is one person who is in touch with them. Okay, let me put it this way. Okay, and this guy is again one more person. This guy is your, let's say, project architect or manager. Let's say manager, let's call it as manager. This guy is your project manager, right? Then under project manager you have I mean, most of the companies, it may not be true for all of them, but 90% of the companies do have similar hierarchy. Then you have something called as team leader. Okay, and then, sorry about this, I think I'll need to, okay, make it bigger a little bit. Yeah, okay, then I'll just take one of the examples. Similarly, it will be for other team leads as well, and there will be multiple developers. Okay, let's say this is a dev lead, so then this will be a dev developer. Let me put this. Developer 1, developer 2, developer 3, right? Similar is the case here as well. Okay. So what happens is, let's say whatever the work that you are getting, right? This is, you are getting that from outside your company's perimeter. Okay. So you are working for that particular XYZ company. Those are your clients or stakeholders, right? But as a developer, if you think from a developer's perspective, this is the person who is actually doing the work, right? But he is not directly talking to the stakeholders, rather he is getting the work from a team leader, and team leader neither having any discussion with the client or the stakeholder directly. There is a project manager in between, right? Well, the project manager is the person from your company who takes the requirement from your stakeholder, right? So this is something called as external, because he talks to an external person, and this is, you can just say, this guy is an internal. Okay. So if you see here, this guy, depending upon what type of work I'm getting a developer development kind of a work, whether getting a testing kind of a work, whether I'm getting a support kind of a work, right? Accordingly, the project manager will send that particular work or the work request or whatever we create, right? Maybe some Jira tickets or some work request or something, in simple word. So that work will be assigned to the respective lead, maybe a support lead or a dev lead or a test lead, right? So the external load balancer, now this is nothing but a load balancer. So project manager works as a load balancer, because depending upon what type of work that we have, it sends back to its further child child node, I would say, right? Now child node can be directly your developer also. Some developer might directly be reporting to the project manager without a lead, right? So, or in other way, it can be a, there is another layer, let's say like a team leader, who can work as a internal load balancer, right? So internal load balancer means the load balancer will take the work from the external load balancer, that is project manager, and then it will distribute to the respective developer. Let's say one is a Java developer, another one is a Python developer, right? So depending upon what type of work that has been needs to be allocated, so depending upon that, the particular developer might be selected by this particular dev lead or an internal load balancer, right? So team leader is nothing but an internal load balancer. Project manager is nothing but an external load balancer, right? So there are these two types of load balancer are there. Okay. So I hope this is clear, simple words, right? So now let's see, why do we need this, right? By now you must have already understood, but in technical terms, I just wanted to, let's say, uh, for a load balancer, right? So what happens is, sometimes what happens is, in the peak demands, right? Generally for the websites, this is majorly for the web applications. Let's say right now also you might be already aware, in India, some big billion day sale is going on. Great Indian Festival on Amazon is also going on, right? So what happens is, for typically in such a peak demand time, or some duration of for a week or so, they get very spikes in their particular network traffic, I would say, right? They get a lot of traffic coming to their website, and now if they do not have any provision to cater those requests, their web application will slow down, either they will crash. Okay, worst case they will crash also. But if you have seen, I mean, I just yesterday served something on the Amazon as well, but I did not even find that, okay, this is lagging, or this is something other than, I've been experiencing for in last week or something. It generally felt the same way that I was using Amazon for the last week also, right? The same experience I got yesterday as well. So what how does that happen in the back end? So that happens because of the load balancer. That's the beauty of load balancer, that in case of spikes in demand, it distributes the traffic to other resources. What happens is, by default, the nature is, if a request is coming from an Asia region, then that will be served by the Asian zone. Okay, so let's say Amazon has their VMs. Let's say they have VMs in India, or in Hong Kong, or in, let's say in Asia, any Asian countries, Australia or any other countries as well, for an example. And at the same time, they also have some some VMs in Europe or in US as well, right? So what happens is, by default, the service is being routed to the nearest region and nearest zone, right? But what happens is, if that particular VM is overloaded already based on its CPU utilization, or we can say metrics, right? Some utilization metrics, right? We can use not just the CPU utilization, but there are other metrics also. So if it is considered as to be overloaded, then automatically load balancer will send that same request to some other region, and end user does not even feel that, right? So that's one thing, that in case of spikes, it automatically distributes to other resources. Uh, um, if there is any network outages or timeouts, right? If, let's say, for some odd region, odd reason, some network outage is there, or your particular VM is timed out, or something is been corrupted. Let's say something, you have installed some web application patch, but it did not work, right? So in that case, what happens is, automatically load balancer understands that, okay, this request is not getting served. Then it again sends that request to the other region, VMs in the other region. Okay, so if there is any lag, right, so response time is more, then also load balancer can help you that, okay, so this particular VM is giving more response time, then that particular request onwards, the other VMs can be taken up by the load balancer, right? So these are some of the reasons why we need load balancer in place, generally for the web applications, right? So web application means, just in simple terms, websites. So basically, a simple website we will create, and then we will understand uh, all these things. Okay, I have a one diagram. I mean, that's not really required now, because I hope you must have got the understanding of this. So that if you see here, people are sitting, let's say like you and me, we are opening Amazon.com, let's say, or Flipkart.com, right? So these are some e-commerce websites in India. And then what happens is, once the request comes from our browser to Amazon's website, Amazon has a load balancer. Okay, so what does that do? That load balancer will send our particular request to either of the VM. So it's a pool of server that we create. This is called as, we will come to this, so this is called as backend service. So one of the VM, one of the instance from the backend service will be selected by the load balancer to serve that particular request, right? So one sec. Okay. So any questions? So basically, in GCP, the load balancer can be, or it will be, software defined. Okay, so you can have in load balancer, in GCP, the load balancer will be software defined. Basically, you don't see that everything will be taken care by the GCP, and it will be software defined. There are two types of it. Basically, you can have physical equipments and everything, but you can also have software defined load balancers also. So in GCP, it will be software defined, and it is distributed in nature. Okay, so don't take it up like, let's say we have a lot of VMs, but what if my load balancer also dies, right? So don't think that way. That's a distributed one. Just like you must have worked upon, let's say, GitHub or something, right? So GitHub is again, it's a one central place where we keep our code. Why do we trust GitHub? Because it is distributed. The GitHub itself, GitHub tool as itself will store your code in multiple different places. So that's how the distributed system works, right? So again, the load balancer again internally is a distributed one. So what happens is you get use the, or you can say works behind single anycast IP address. So what does this mean is, just in simple words, right? For all the stakeholders, there is only one person, like a project manager, right here. So they know the contact of project manager. They don't care how big is the team, and they don't need to even know what is your capacity and all. They just need to give them the work to the project manager, right? Similarly, all you need to know from a end user perspective is to know the IP address of the load balancer. Of course, this VM also will have their own IP addresses, but that needs to be known by your load balancer, right? Not by you as an end user. You just need to hit the IP address of the load balancer. It's load balancer's job to take care of the request, right? So then it will help you to auto scale your infrastructure. We get automatic failover, right? So if one of the VM is failed, then the same request will be served by another VM as well instead of that. It's a managed service. So GCP takes care of all the patches or whatever they want to do on the load balancer. Again, it's a software defined, so it will be taken care by them. And you have integration with CDN is also possible, right? So we'll see what is CDN as well. So just understand that. Okay, so CDN integration is also possible with load balancer. Now there are classification, and uh, we call it as balancing mode. Based on balancing mode and based on deployment mode, we can categorize the load balancer in two different way. Okay, so for balancing mode, let's say if your traffic is coming from internet to the backend, right? Then, or backend VM, I should say, right? Then it is called as external load balancer. Just now I have shown you on the project hierarchy example, right? If the traffic is coming from internet to backend, I mean internet means something external, right? So if it is coming from external person or external source to your premise, then it is external load balancer, right? If his traffic is in or among the VMs, backend VMs, then it is called as internal load balancer. Okay, we'll come to all of these, but just understand this classification. It's very simple. If your traffic needs to be distributed or balanced internally, then it is internal load balancer. If the traffic is coming from an external source that you want to balance or distribute, then it is external load balancer. Okay, then deployment mode is where you deploy it. Okay, you can either deploy that as a global is nothing but multi-regional. Okay, multi-regional, or it can be regional. So you can deploy your load balancer for just single region. Okay, so under the same region, the all the respective zones, right? We have zones under the region, correct? So that will balance all the load for that particular region. Or you can make it as a global as well. So in case of global, it will manage the traffic for the multiple regions. I hope you got the up to this much. What is the basic of load balancer? Then there are two prerequisites: managed instance group, and for managed instance group, we need an instance template. So I'm just going to cover these two as well. So prerequisites, or not prerequisites, some basic building blocks, I would say, building blocks. For any load balancer, you need instance template and then instance group. Okay. Uh, uh, okay. So instance template, instance. Let me just finish these two, and then we'll take up the questions if there are any. Right. So in simple words, instance template is nothing but it's like a blueprint. Okay. It's a blueprint of your instances. So let's say if you want to create multiple similar instances, let's say in example we have seen, right? In this particular example, you see a pool of servers. So that means you need a lot of similar VMs to serve the, let's say you have 50 VMs, and then you have a load balancer against that, right? And then it's responsibility of your load balancer to balance the load between all those 50 VMs, right? User do not hit the IP address of your VM. They only hit the IP address of your load balancer, right? So now how you create those 50 or 100 or whatever, 10,000 VMs if you need in your web application, right? How do you create that? You can create a blueprint. You can create a blueprint in GCP for that instance. This blueprint is just a blueprint. This does not create any instance. This does not incur any cost. This does not charge, they do not charge you for creating blueprints, right? Because VM itself is not created yet. It's just a blueprint of your instance. So this will be just like your the form that you get for VM creation, correct? The same form you will get for instance template creation also. Okay. So or a simple words, right? If you go for if you want to buy a home, right? So you have a floor plan for that, right? So this much will be my entire plot, and then this much I have two bedrooms and their dimensions and something like that, right? So that's a floor plan. The home or your house has not been constructed yet, right? So that's the blueprint, and then you can create similar instances or instances of your house, let's say an apartment, right? So you can create the similar flats in a building, right, with the same blueprint. So it's the same concept. So basically for mass creation of virtual machines, it is being used for mass creation of virtual machine, and it can be global or it can be regional. Okay, depending upon your need, you can create global or regional also, and then you can use them in MIG. Okay. Okay, instance group. For now I'll say instance groups, right? And then instance will come to instance group as well. Okay. There is nothing much to discuss on the instance template, but I'll show you on the console. Okay, so but I think you got what I'm trying to say. It's just the blueprint of your virtual machines, and using that you can create very identical mass creation of, I would say, identical VMs, right? Exactly same identical VMs we can create. Now what is instance group, right? I have a diagram for that, I think. Yeah. So what is instance group? Instance group, if you see in this particular diagram, now you have an instance template. Take a black pen. You have an instance template, so that you are feeding to a group, instance group. What it does is, while you create an instance group, you can say I want minimum 2 VMs, maximum 10 VMs, maximum 50 VMs, right? automatically that will use this particular creation process, will use this particular template and will create those many copies of the VMs, virtual machines, the actual virtual machines. This will, I mean, depending upon the number, this will cost you, right? But this will not. The instance template will not cost you anything, but when you create a VM out of it using it, then it will cost you for that those number of VMs, right? So it's basically group, as it as the name says, group of identical virtual machines, but managed as one single entity. Yep, managed as one single entity. So let's say we will not call them as, okay, VM1, VM2. We don't care how many VMs are there. Okay, but we all we care is about that group. Whenever we will address something, we will address to the group. Then it is responsibility of that instance group will have some features. It will be responsibility of the instance group to do rest of the things on all those VMs. Let's say auto heal. Okay. Okay, so what is auto heal? Auto heal or self healing? Both are same. Sorry, self healing. Okay, so what does auto heal or self healing means is, let's say in a simple example, in my team, let's say I'm a team lead, right? I have four developers or three developers, and one of the developer is felt sick. Then whatever the work is being assigned to that particular developer, or whatever is the new work that is coming, I cannot assign to that particular person because he is out, right? So similarly, so what happens is I will either take up some other developer for that particular short duration, maybe for a week or something. I will maybe I'll get it from other resource pool for that short duration, or either otherwise I'll have to balance between the existing ones, right? So auto healing in the works in the same way. Instance group, what does is, if any particular VM has some timed out, or it's not healthy anymore, then automatically it detects the health of underlying VMs, and creates additional VM if needed, right? Then this automatic, and this is taken care automatically as part of the auto heal process. It will be taken care automatically. The instance group is controlled by instance template. So if you make any changes in the instance template, automatically the underlying VMs will also get replaced automatically, right? So if you want to change the OS of that, right? So you just change the OS in the your instance template, automatically all the VMs will be replaced underlying, right? And since you do not communicate directly with the VM, you don't even have to worry about their VM's IP addresses and all, right? So automatically it will be changed. The configurations will be changed for the underlying VMs, right? Again, life cycle that we have seen, right? Life cycle of the VMs will be dependent on the instance group. So if I delete an instance group, automatically my VMs also will be get deleted because those are tagged under that instance group. Okay. So again, as I said, there are a couple of features, right? So one of them is auto heal, another one is auto scaling. So addition, I can say, adds new VMs when spike or whenever needed. Basically, there are a lot of other criteria also. Um, Whenever there is that particular criteria we have set and it has met, then automatically it will add new VMs, or it will remove the VMs if needed. right? So you can get this feature also with instance group, right? And you can deploy the instance group behind the load balancer. Now in this particular example, right, just above here, that these pool of server is nothing but your instance group. You have deployed that under load balancer. So what happens is, load balancer, when you deploy a load balancer, you will get an IP, one IP, right? Single cast IP that we have seen. So that with that IP address, external people can directly send traffic to or directly hit the load balancer, and then load balancer will work with instance group. That's how they are interlinked with each other, right? So the backend service that I was mentioning, the backend service is made up of instance groups. It can be multiple instance group, it can be single instance group, anything. And then you can create zonal or regional. Okay, so it can be a zonal or it can be deployed as a at a single zone. Okay, then we have rolling updates, right? So let's say Google has put down some um, patching or some patches or something else is also there, right? So what happens is it happens in the rolling fashion. So like first 25%, then next 25%, like that, right? We have seen rolling updates earlier as well, right? Now there is one more. So basically category, there are multiple categories. One is stateless, stateful, and third one is unmanaged. Okay, so stateless is basically the underlying VM's instance state. Okay, state, I mean like instance name, their persistent disk, any metadata on that, right? The whatever the events that has been created, been logged on those underlying VMs, all those are nothing but the state. So if your instance group, you want to keep a track of that, then it is called as stateful instance group. Okay, instance group. Okay, if you don't want, then it is stateless instance group. Okay, and then these both are called as managed. These are both are managed. Managed means you will take care, sorry, the Google will take care of all the security patching and rest of the things for these groups. But if you don't want, right, Google to manage, then you also can create unmanaged instance group. So adding that, removing that, auto healing, all those things will not be possible with unmanaged instance group. That you have to take care, right? So you will not get auto scaling, you will not get auto healing, right? So that is unmanaged instance group. We'll be using stateless managed instance group. These are also called as MIG. So here onwards I'll be using managed instance group, right? I'll be using the term called as managed instance group, MIG. Okay, so I think we have pretty much covered the theory part. So any questions until here? Else we'll go on the GCP console and I'll walk you through how do we create an instance template, how to create an instance group out of it, all those things I'll show you. Can you explain balancing mode again? Balancing mode. Okay, balancing mode is very simple. Balancing mode is basically the traffic it's coming from, right? So you have in this case, let's say in this particular example, okay, so there are two types of load balancer. For this guy, dev lead, it's an internal discussion, right? He is taking the work from project manager, he is giving that work to underlying developer, right? So the communication, whatever is happening, is inside the company perimeter, right? The project manager also belongs to the same company as the team lead and as the same as the developers, right? So that is the internal communication. So this guy is nothing but a internal load balancer. And external load balancer is like project manager. This guy is taking work from some external party, some XYZ company who is having a contract with your company, right? So project manager is a person who is a face of your company for external world, right? Balancing mode is nothing but a classification of load balancer in these two terminologies, external or load or internal load balancer, right? So that's the balancing mode. uh, okay, managed versus unmanaged instance group. Can you please explain the difference? So managed versus unmanaged. Managed, there are only two things. Okay, let me write it here, that no auto scaling and no auto healing, right? I think these, when I write this will be self-explanatory, but if you create unmanaged instance group, let's say for 50 VMs, okay, so it will create 50 VMs for you for the first time, but you cannot auto scale them. Okay, you can, it's like a static group of your VMs. You have to control, if you want to add one more VM, you have to go and edit and say add more instances like that, or remove instances like that, right? So auto scaling will not be there. Auto healing will not also not be there. Auto healing means automatically, if a health of a particular VM is not, it's not responding, right? Let's say something corrupted on the VM, your website is not serving any response. It's not responding, or it's not serving any request coming to that VM. Then there is something called as health check. So that health check can be configured with instance group, but with unmanaged instance group, that health check you cannot attach to that, and because of that, auto healing also will not be possible. So it will not create replacement VM for the errored VM, right? So that's the auto healing. That is also not possible with unmanaged. Unmanaged is basically you manage it, not Google, right? I hope that is clear, Dia. Okay, so let's go to the console and go to, let's type instance template. So under compute engine, where we created VMs, right? Let me just check accidentally. I don't want any other instances to be running. I was thinking to create one script which we can, I was just trying to automate that. So by end of the day, I just need to run it. Whatever are the maybe VMs, load balancer, buckets, whatever is there, it will flush everything from my free tier account. Last time, accidentally, I had got 5,000 bill on my account, my paid account, because I kept one of the demo VMs up and running for the entire month. uh, okay, so I don't have any instances. So if you see just below the instances, you have instance template. Okay, now let's create one instance template, and I'll be asking you one simple question. What is the difference between the form that you see for instance template, that is this one, against when you create a instance, VM instance, when you create a VM machine, against when you create instance template? What is the difference that you see on this particular page? We have created multiple VMs in the last session, right? This looks pretty similar to that. So what is the one difference that you see? You can post your question. Meanwhile, I'm just creating one simple instance template. What is the difference that you see? I'm just giving a name. Then I'm also, I can add label. I can select all these machine families. I can go for, like we have done it multiple times, N1, F1 micro. Then if I can do all these things also, the boot disk. I can change the OS as well, right? So all these things also I can do. It will attach persistent disk of 10 GB, service accounts. right? All these things are there. What is that one thing that is missing? That will give me an idea how many of you are trying to do the practice, who are trying to practice at home. What do you think, guys? Anyone? At least try out instance group is missing. No, instance group, we have not yet gone to instance group. Instance group is a different area. Perfect. Dia, your answer is exactly correct. Anyone else wanna try? Network. Okay, no. Network is there. See, I'll show you in advance. Network. I have all those same options. I can select the VPC as well from here. Okay, so no more riddles. It's the region. You see here, there is no region here. In the VM form, you will see a region and zone here, right? Why? Because the template is not creating the VM itself, right? We are just creating a template. And when you create, these are estimated cost for the VM instance created using this template, right? This template is not going to cost you anything, but if you create a VM out of it, that will cost you this much. So this is also same. This is also similar on your VM page, but the only thing that is missing is here you don't have to select any region because it's a template. Then you can use this particular template for creating VMs in any other region, right? So that's why it doesn't ask you for that particular region or zone. Now, uh, I'm just attaching one network tag. Okay, I'll come to this one in a bit. Um, and then in the instance, in the VPC, I'm going to use default, and I'm going to use, let's say, East 1 external IP. For now, I'm just keeping. Okay, I'm just keeping. I'll tell you why I'm keeping that, but that's okay. So I'm just keeping the external IP. So whatever the instances will be created using this template, they will also have an external IP. Okay, this is just for demo. In actual real world, you won't have external IP. You will set it as null there. Then now, if this is the new area in the management, okay, I can I can expand this, and if you see here, I can write a script here. I can simply write sudo commands or ls commands or whatever, cat command, whatever I want, I can write here. What will happen is whenever we create a VM using this particular template, those commands will be executed. I think I have already explained this in the life cycle of VM, right? So go back to that particular diagram and understand that when the VM gets provisioned, so it's being boot up for the first time, this particular script, the commands that I will include these will run on that particular VM for that first time, right? So it's kind of an automation that you can attach to your VM. Similarly, you can also do the shutdown shutdown script also. And this is the, let's say, in place editor. You can put the script command here, or you can add an item here, right? So what I can say, I can say there are some keywords. So that is start up, no, startup script URL. Okay, so sorry, what happened? Okay, so startup script URL, and what I can do is I can give a path of a shell script also. Okay, like the way I have given. Okay, we'll come to this. I'll show you what is there in this particular shell script. But if you don't want to write the commands directly here, you can also give an external path of your shell script, and that shell script should be accessible to the VM. So this is Google given shell script itself. So I'm just giving, I'm attaching over here, and that will be visible to public. So this is public available. So that's why my VM also will be able to download and run it, right, when VM gets booted for the first time. Now rest of the things I will keep it as it is, and I will create the template. Cost div cost is different between the region, like same VM will cost more. Yes, exactly, Shrey, that's a correct point. So depending upon the region where you create the VM from, in VM in that particular region, depending upon that region, your costing will be different. Yes. For simplicity, I have created a template with this particular name, but you can create a global, a simple template also you can create in any other region. Okay. So now if I want to create an instance group out of it, you remember in the diagram for instance group, we need an instance template. We just created an instance template now. Now I'm hitting to going to instance group, and I'm hitting instance group create. So if you see here, stateless, stateful, and unmanaged, I can select any of them depending upon my need. I don't want much of my overload as well, overhead on my instance group, so I'll create stateless. But you can create the same thing you can do with stateful also. It will basically monitor and keep some more metadata with it. Okay, so here let me call it as east1 MIG, right? I'm going to use that particular template, right? So what does it say? Require subnets only. Okay. So since I had created a subnet US East 1, I can now use this particular template. Okay. Now I can deploy this particular instance group in multi-zone. So if I select multi-zone, one second, multi-zone, and then US East 1, and I'm selecting this. So what will happen is the VMs that gets created using my instance using my instance template in my group, those can be created in any of these zones. In any of these zones, it might get created. Okay. Target distribution. Let's just keep it even for now. Then if you see here, the auto scaling possible with these three options. One is on. On means it's simple, it can add and remove also. Scale out, it will only add new instances. Off means it will not auto scale, right? So let's keep it on. And for if you select on, you just need to give some let's say some random numbers, minimum and maximum threshold value, so that I want two instances to be running all the time. So minimum is two. If there is any spike on this particular instance group, okay, then instance group will automatically add VMs up to 5. So maximum limit I want to be 5, right? In your project it can differ, right, depending upon how big instance group that you want to create. You can select that particular maximum threshold as well, right? Then if you see here the metrics, this is what I was talking about. So this is the criteria based on which the auto scaling will happen, right? So if the CPU utilization of particular VM of or these two VMs, these are two existing VMs, right, minimum VMs. So if the 60% utilization is taken, then it will add one more VM. If 60% is done on the entire three or all those three, then the fourth one will get added, right? So now since we are going to we're not be going to will not be able to create lot of traffic, so let me set it to something like a lower value, 40%, right? So that when we are going to create a load balancer, we should be able to see that new VMs are getting created, something like that. So I'm just putting it to some lower value. And typically in projects I have been using that to 80, right? 80-85% if CPU utilization is done, then create a new VM. You don't want multiple VMs to get created, even though capacity is available with the existing one, right? Just for demo, I'm keeping this as 40. Okay. Okay, so that's done. Just I think cooldown period. Okay, so cooldown period is basically um, as it says here, right? So basically, what happens is, uh, let's say you have a web application, right, and you are deploying something on your VM. So whenever a new VM is getting created, right, so something has to be copied, which will be done by instance group, right? Because in instance template you have written that shell script or whatever, right? So that all these things needs to be done on that particular VM. Until that all that setup is done, you cannot use that VM for processing, right? It cannot process unless and until it has a web application installed, right? So that web application and everything needs to be installed, and whatever time it takes for that you need to give that particular heads up time, so that after, let's say, new VM getting added, so once it has been started, or once it has been provisioned, after that the 45 next 45 seconds, this instance group will not send any traffic to that VM. It will wait for this particular cooldown period. After 45 seconds, it will assume that okay, this setup has been, I mean, this VM is up and running now and ready to serve the traffic. So that's a cooldown period. Okay, so let's keep it as 45. It's nothing fancy we are going to do on those VMs, right? Then auto healing. So you can create a health check over here, right? So let me show you. Let me duplicate this. Let's create a health check. Okay, create a health check. VM health checks. Create health check. So basically, what is health check? Health check is a way. I'll show you 1 second. Let me just try to create and I'll explain you. This is very simple. Again, this is related to that auto healing feature that I've been telling, right? So then let's keep it as global TCP. Let's make it as 22, proxy none, fine, and let's keep these timings also same. That's fine. So what happens is, now coming back to this particular diagram, right? Okay. Okay, this one. So auto healing, right? This is what we are talking about. So it will detect the health of underlying VMs. So if one of the VM is not responding, how will this instance group will come to know that this VM is not responding, right? How it will know? So it has to have some service attached with it. It is called as health check. I'm sorry. Let me take a pen. So it's basically a health check service. Then it directly monitors the health of every VM. If there is any discrepancy in the statistics, or let's say a VM is not responding, so what happens is this particular health check keeps on sending a signal. This keeps on sending signals every, let's say, 5 seconds or 10 seconds we can configure, and then it will wait for this will happen with every VMs. Let's say here you have 5 VMs. This will send signals to all those 5 VMs, keep on sending those five signals to those 5 VMs, and it will expect that they return a response. If a particular VM does not return back to health check, then that health check will mark that particular VM as inactive, right? Or dead, right? Or unhealthy, right? It is called as unhealthy in GCP. So it will mark that as unhealthy, and after that, instance group, it will tell the instance group to auto heal it. That means it will be replaced by another VM. Okay, so that is what we are trying to create. So what we are doing here is, what type of signal do you want? I want some SSH which runs on 22, right? Just the way we send ICMP or SSH or on browser you hit amazon.com, right? So basically you are sending some signal to amazon.com. Similarly, I am going to use TCP protocol. I can use HTTP with port 80. I can use SSH with port 22, right? So I'm just setting 22, let's say here. Then here some criteria, right? Check interval. How frequent you want to send that signal from health check to your VM, right? So every 5 seconds send it. And if that does not respond back in 5 seconds, then consider that as timed out, right? So if the VM does not send back the response within 5 seconds, then health check will understand. Okay, then that particular signal will be considered as failed. Similarly, if we get health check gets the response, if health check gets the response within that 5 seconds, then this health check will mark that particular signal as healthy. Okay, so now these are the two things. So if I get two consecutive healthy signals back from VM to my health check, then that particular VM will be considered as healthy. If two consecutive failures have been received by health check from the VM, right? So that means health check will mark that as an unhealthy VM, right? I'm not getting, I sent two signals, but I have not got any of them. And those has to be consecutive, right? So then it will mark that as a unhealthy. So let's keep the default like this and let's create this health check. What was the name? Health check demo. Okay, so it has created. Now we'll have to attach this particular health check in this particular instance group, right? So let's go back to the instance group. What was that? Health, right? So health check demo, I just attached, and it says the same things which we seen during the creation. Then initial delay. Initial delay, let's keep it as default. Initial delay is very similar to cooldown, okay? But it's basically for the healing, right? Generally for this 45 seconds we are waiting for this particular VM to start serving the actual traffic by the end user, whereas initial delay is in seconds, like 300 seconds, right? This is for 5 minutes, let's say, right? So this for the first 5 seconds auto healing will not be possible, right? Because health signals will be sent only after these many seconds. Okay, let's keep it that way. Think anything do we need to do advance? No, that's okay. Let's create this instance group. uh just one request, guys, pay a good attention to what I'm teaching, because we have extensive topics to cover. If you miss something and if I keep on repeating, it will be difficult for everyone. You'll have to extend otherwise. I'm not saying don't ask questions, but just pay a little more, be attentive, because these are little get sometimes get complex to understand, right? So we are just creating an instance group using the template. We have not so far gone to load balancer also, okay? And the minimum that we have set is 2. If you see here, from 0 to 2 it is going. So because the minimum we had set is 2 VMs, I want a minimum 2 VMs. If you see here, those are getting added, that's why those are still unhealthy. Okay, so now if we go to the VM instances, those might be getting created in VM page. You might be able to see them. Refresh. It got created. So if I just refresh this particular instance group now, okay, so everything is healthy, 100% healthy, right? So if by any chance something gets corrupted on one of the VM, automatically there will be another third VM. And if you see here, we have not given any name. So it has taken the name from the MIG. This is the MIG and some random value to some random 4 alphanumeric characters it has attached to that particular VM. We are not going to use this VM directly, but we are going to use this instance group, right? We are not going to directly communicating with the VMs, right? Because we are going to create this pool of server we have created. We are going to put a load balancer in front of it, and we are going to only send the traffic to load balancer, right? So just why I have created that template with external IP, I said, right? Because what happens is, when I created the template with external IP, whatever the VMs getting created, those also will get created with external IP, right? So in typically in your project, in actual projects, these will not be there, because in the template itself you will set it to none. So the VMs also will not have external IP. Why I have done that is to show you and confirm one more thing. One second. So basically, you remember that startup script that we had created, right? Not created, but supplied when creating an instance template. So if I show you that, and I want to show you the contents of that, I think for that I don't need this. I can directly go to my repository, startup script. This is the startup script, okay? So the contents of this particular, see, if you remember, we had given this particular startup URL, and I have passed this particular value while creating the template, right? So what happens is this particular shell script get executed whenever there is a new VM. These both the VMs have been executed with this particular shell script. Okay, what are the contents of this shell script? I have not shown you. Those contents are this one. Okay, so what I'm doing is I have just some shell script commands here. So it is installing apt-get is to, it's like an install. Okay, so it's going to update all my binaries and my libraries in my VM. Then it is going to install Apache 2. Okay, Apache 2 is a web server. Basically it's to make your VM as a web application, right? Then it is going to install wget. There is one more tool. This is just like you install softwares on your Windows laptop. Similarly, apt-get install is the command to install some tools, let's say Notepad or Apache or wget, right? So all these are nothing but tools in Linux. That and apt-get install is nothing but a command, and then you just tell them, okay, which tool you want to download on this particular, install on this particular VM, right? So this particular script is getting run on all the VMs, right? So after that, what happens is, basically, let me show you what happens is, this is the VM. Okay, now you want to uh, make this as a web application, right? So that you can hit the IP address and you will see some website. Okay, so for this, there is this particular web application needs to be deployed here. Okay, and it needs to run here. So it needs to execute this, right? So it has to execute. So for that you need something called as Apache 2. Okay, just understand this way, you need Apache 2 to run the website, right? So that's why I'm installing Apache 2. I'm installing wget. Wget is to download something, right? So wget, if you see here, wget, and I am in downloading one PHP file. PHP file. This PHP file is nothing but your website. Okay. So let's say some Hello World or whatever the websites that you see. Let's say Amazon.com, right? So whatever the contents that you see, let's assume that that is a PHP file behind the scene. The same PHP file. Similarly, I have a customized PHP file. Basically, it's given by Google only. Okay, so we download that on that particular VM. Everything is executed on that VM. So that PHP file is downloaded, and then it is doing some replacement in that file and all, right? So what will happen is, whenever we hit the IP address, we should be able to see that web page, whatever PHP file contains, right? So this now runs that particular PHP file. Okay, and that should be visible on my browser. So whenever I hit from here I hit that particular IP address, right? So I should be able to see this website on my browser, but I'm not able to see it, right? Why? Because I don't have the firewall rules. Okay, so for that, let's hold on for a minute. Let's hold that for a minute. Okay, I'll show you how to create those firewall rules and all that we will take up in the load balancer. But till now we have created MIG, we have created instance group. So do you have any questions on all these? So otherwise, let's break for 5 minutes. Okay, first let me answer the questions, those are pending. Then we'll break for 5 minutes and then we will finish the load balancer part. So I'll first explain you one of the architecture and then we'll go for the demo. So let me just take the questions. Oh, there are a lot of questions by Shrey. Cheapest VM, yes. Depending upon the instances, those are getting created from the template, and wherever, I mean, if your regions are different, so depending upon the region, the costing will be different. Please explain stateful versus stateless. It's basically more metadata that it will maintain in stateful, and it will not maintain the metadata like its CPU utilization. It will just track. It will just keep a track of those metadata. Okay, nothing else. Basically, like attached persistent disk or its instance name, how many time it restarted, some metadata about the state of that particular VM. It will uh, keep with it. That is your stateful instance group. Stateless is without the metadata of the VMs. 90% of it is similar. Unmanaged is something different. Also, any example of real example when you should go for managed for versus unmanaged? I never go for unmanaged. These are just one. In GCP, there are a lot of things which you those are just provisions like unmanaged instance group. Nobody uses unmanaged instance group unless and until you don't want auto scaling and all those things, right? Even you can get those features if you want complete control of those VMs to be with you. You don't want them to get deleted automatically and replaced with another VMs. So that is auto healing. You don't want this kind of feature, you go for unmanaged, right? I have never used unmanaged so far. All the time we have been using managed instance group because we never know if something gets corrupted automatically. We don't want to go in troubleshooting, then find out, okay, this has gone down or something like that. Automatically, we are creating the instance group because of that. We don't want, we are creating that like a black box. I don't care what is happening underline, right? Let Google handle the healing and everything. So that's why 90% of the time you will create managed group. Understanding if you know the application is not critical, how much traffic, we go for unmanaged. No, if you have much traffic, you never go for unmanaged, right? You will have to keep on adding or removing the machines by yourself, right? You will go for the managed one only in that case also. If you want finer control and you want to have the control of not a machine not getting deleted, or you want to add whenever you want, the VMs should get added. When you want to manually remove the VMs in your instance group, that time you go for unmanaged ones. In Hadoop, we have node manager, which checks the heartbeat of the every machine. VM health check seems to be very similar. Exactly. Yes, I am also from the same background. I know those signals that have been sent from your master node to your node manager to your slave machines, let's say, right? So it is very similar to that. Okay. Any other questions where the SSL certificates unconfigured? Can we cover domain mapping, CNAMEs, etc. SSL certificates? No, dear, sorry, it's not a scope of the particular course to cover all those things. So let's not digress on that. Maybe I'll check what you need there, and I'll separately provide you. Uh, I'll see to it what you want, but I can't cover in this one. Um, Shrey, so unmuting I said right in the first session. Unmuting, I can unmute you at very end of the session, right? Not right now. Do you face any network issues or anything? Just uh, drop and rejoin, I would say, and let me know if you have any other doubts. Then let's take it up at the last. Before removing the VM, auto scaling take the backup of the data. So yeah, I mean basically it is written on the persistent disk, right? So typically, in general cases, the backup or the websites do not write anything on the VMs, correct? You might have seen the VMs, sorry, the websites when you if you have worked upon the web applications, right? So web applications do not write on the VMs. They write it into the database. Maybe it is a non-SQL database or it is a SQL database, depending upon your need, but we do not write anything on the VMs. Okay, but still, to answer your question, yes, it is attached with a persistent disk, right? So so even if the VMs gets deleted, it will still be on the persistent disk. Any questions? Any further questions? Otherwise, we'll break for 5 minutes, and then we'll resume with the load balancer uh, demo. Okay, so yeah, I'll be also back in 5 minutes, and then we'll resume back. Okay, thank you. Enjoy the break. Okay. Okay, I hope everyone is back. So now let's jump on to the load balancers. Okay, so the first one we'll discuss is STTP or HTTPS load balancer. Okay, so is my audio clear? Just I need a confirmation. Mm, mm, mm. Okay. Okay, so basically now the load balancer, there are multiple types, right? So the types can be in different ways. So basically there are, before I start with the actual load balancer, right? Uh, okay, let me say types. So types can be depending upon the deployment, depending upon balancing mode and deployment mode, we can we can have different. So depend what is balancing mode, external or internal, right? So external or internal. Then deployment mode can be regional or global. Global means multi-regional, right? So these are the two classifications that I have already explained, right? So the load balancer will fall under one of these categories, the combination, because these are typically two different types of classification, right? This is deployment, where it is deployed, and this is how it is balanced, right? So how it is going to balance the traffic, right? Balancing part. So depending upon these combinations, these load balancer are classified, or there are multiple load balancer which are classified using this combination. So uh, HTTP or HTTPS load balancer is a type of load balancer that it is an external load balancer. So basically traffic will be from internet to GCP, right? It will be from somewhere else, like in internet, from browser to GCP, right? So GCP perimeter will get the traffic from the browser, right? And then this will reach, that particular request will reach to this particular load balancer. This load balancer is an external one. Okay, this is a global one, right? So you can deploy this at multiple regions. Okay, that means backends can be in multiple regions, right? So this is an external load balancer. This is a global load balancer. Okay, so this is an external load balancer in a balancing mode perspective. In a deployment mode perspective, it is a global load balancer. You can deploy this as multiple regions. So you can have a web application, let's say, and that web application is having a load balancer. That load balancer will route the traffic to, let's say, US region, Asia region, or any other Europe region, let's say, right? So your traffic can be served from the VM sitting in US also, and Europe also, and Asia also, let's say, right? So this is a the global load balancer type. So all the traffic, as I said, will be using single anycast IP. Single anycast IP means even though the load balancer is a distributed one, right? But still the load balancer IP will be it will be only one single IP that you need to remember, right? And then you have to hit it. So if you hit that particular IP, the traffic will be first go to a load balancer, and then load balancer's responsibility to distribute that traffic to the respective backend service, right? Then it works on protocol, HTTP or HTTPS, right? So HTTP works on which ports? It works on 80 or 8080 ports, right? This is basic networking knowledge you need to know, right? And HTTPS works on 443 port, right? Similarly, this is similar to SSH, right, which runs on 22, right? So this is what is some characteristic of HTTP or HTTPS load balancer, we can say, right? It uses proxy. What is proxy? You must have seen, right, in your project you said proxy. When you go to office, you connect to office LAN, they need some proxy settings and all those things, right? What is proxy? Proxy is basically letting it's basically when you are connecting from any external sending a traffic from any external IP, let's say external machine, right? if you don't want that if you don't want that particular client IP address of your client machine, right, not to be propagated inside your network, then you have proxy in place. So what does the proxy do? Proxy will offload, what it says is offload the IP addresses, IP address, and terminates the connection at proxy level. Then it generates another connection with another IP. So basically, it does not uh, forwards the IP address of your client into your network. Okay, proxy stops it there itself, and then it creates another connection. It's not that your request is getting rejected, but for serving the traffic, or for serving your request, a new connection is made from your proxy to your backend. Okay, we'll come to this when I show you the architecture diagram. As this is external, it supports IP v4 and v6 both. Okay, external load balancer supports both the type of IP addresses, whereas internal ones only supports, I can write it here itself, only IPv4 are supported for internal, and for this one IPv4 and v6 both are supported for external ones. Okay, default nature, we can say send the traffic to closest region, because it can be multi-regional, right, which is global. So the by default it will send to the closest region, right? And this is layer 7 load balancer. Okay, now this is a part of your networking. You're typically in computer networks, there are multiple layers of OSI model, right? So this is OSI model layer 7 load balancer. So typically your computer networks are categorized in multiple layers. Okay, I have included that in your basics PDF, right? So your OSI model has 7 layers. So the it starts from actual your physical what I can say equipments, then you have data, the network, transport, session. There are multiple, these all 7, I don't remember all of them, but the topmost is the application layer. Application layer is the one which is a end user facing layer of your computer networks. That is your application layer. So this particular load balancer works at an application layer. So this is also called as application layer. Layer 7 is application layer. So this is basically public facing or end user facing. That's why we are going to use the browser to see this load balancer in action, right? We'll be using, again I'm repeating, we'll be using web browser to see this particular load balancer in action, and for that we need a web application, right? So let's say like when you hit amazon.com, you see Amazon's website. Similarly, we need some website to see on the browser, right? Then only we'll be able to understand that this load balancer is working, right? So that is why I was explaining. Now coming back to this particular explanation, that is why I was explaining that particular shell script, that we have created a website on the VM. Whatever the VMs that are getting created as part of your instance groups, right? These VMs, they all have that web application installed, because we ran that script. We ran that script on each of these machines using templates, right? We have embedded this script in template itself. So all the VMs will have that particular website, this PHP file embedded already in those. But when I hit the IP address, external IP address, I'm not able to access it, right? So I said, we'll fix this particular issue. That's okay. But I just wanted to tell you that this is an application layer load balancer. We need some web application, and we have deployed that in one of the instance group. And since it's a global one, I am going to create one more instance group in another region, and then we will try to balance the load. Okay. So then I have one diagram. Let me just come to this diagram. Okay. Okay. So this is the diagram for the HTTPS load balancer. HTTP or HTTPS, both it can work with, right? So if you start from here, right, whenever there is a new request, one person is sitting on this laptop and he is sending some request, right? So via internet, it comes to the GCP. So that means this is external, right? This is external internet to GCP. Then this goes to Anycast IP, the IP address. Typically, there is some DNS server. We don't want to remember the IP address. In demo, we will be using IP address only, but in typically you will be using DNS to hit, let's say, xyz.com, www.xyz.com, and that will have an IP address of your load balancer mapped. So the traffic will go to this particular Anycast IP. Then Anycast IP has this is the internal components of your load balancer. Okay, so what it will do, that IP address will route that particular request to global forwarding rule. What is global forwarding rule? It's basically depending upon whatever request you get, right? It checks the data of that particular request, and then accordingly it will check the proxy, if that particular request, whatever it comes, right, as a JSON or something, right? If you are coming from that background, you will relate this, but it's okay. Just understand that it will check the metadata of that request, and depending upon if there is any proxy details mentioned, then it will go to that particular proxy, right? So if you have the proxy details, that will be forwarded to that particular proxy. That particular request will be forwarded to via that proxy. Now what happens in the proxy? This will terminate the connection here, right? So what will happen is, this client IP, this will also have some xyz x.x.x.x, let's say, right? So this particular IP will also be there in this request, correct? That IP will be stopped here. Okay, it will be stopped here, right? It will not let it go in the further in this particular process, right? That's what the proxy does. So proxy will terminate that particular session, that particular connection, not session. The session remains the same. Okay, session remains same entirely. Okay, but it will create another connection from here for the same session, and it will not preserve, I mean, it will not uh, push that particular client IP further in the process. Okay, that's all the proxy does. Okay, then the traffic goes to URL map. Now this is very important piece. So URL map is like www.xyz.com and slash, you must have seen some web address like this, like slash audio slash x, some random 123 number, right? So this is one file, right? 123 is one audio file. Then let's say there is a video file xyz.com. The address will be little bit different. Let's say like video.hd. Then something. Uh, One sec. Let me scroll it a little bit here. Okay. So this will be like 123. Then this will be like 345, and www.xyz.com video dot sd that 345, let's say, right? So what I'm saying here is, if the request is for the audio, then it will go for the audio. So for audio, let's say you have another one MIG, so automatically it will forward to that MIG. If it is you have a, dedicated MIG for video rendering, HD video rendering, you might have another MIG, right? Then you might have MIG3 for standard definition. This is for HD videos, this is for standard definition videos, low videos, right? So low quality videos, let's say. So depending upon your need, your URL, right, it might, you can redirect that to the respective backend. MIG is nothing but your backend, right, that sits behind your load balancer, right? So depending upon the URL map, I mean your URL map will forward that to respective MIG. Okay, and that MIG is nothing but, these are the your MIG. This is your MIG, this is your MIG. Okay, right, and those are connected to your backend service, right? And backend service uses firewall rules again. Basically it checks whether it is allowed or not, and then it uses, let's say here they have shown only one VM, but you can have 50 VMs, 100 VMs, anything, any number of VMs, whatever you configure. In case of ours, we have minimum 2 and max 5 we have set, right? So depending upon the load that we get in MIGs, those will be adding or removing, right? And then this is again your VPC. Okay, so VPC will have your firewall rules. Okay, sorry, I don't want to rub this out. Okay. Hmm. And as I said, health check also you can attach at two places. One at your instance group also you can attach, and the health check you can attach to your load balancer also. Right now in your in our demo or walkthrough which I have showed you, I have attached it at MIG level, but I'll remove it. Okay, basically you can control that at the load balancer level also. Okay, so this is all about the simple architecture of your load balancer. Now let's see the same thing in action. Okay, uh, but before that, um, in load balancer there are couple of things more. One is CDN you need to know, and another is Cloud Armor. So let me, Armor is like this, I think. Huh? So what is CDN? What is Cloud Armor? We'll see Cloud Armor first. Okay. For Cloud Armor, I have a diagram. Okay. Cloud Armor is basically it's like your guard. Okay. To protect your network from hackers, or you can say DDoS attacks. Okay, what is DDoS attacks? It's distributed denial of service attacks. Okay, so basically what generally typically with very common practice in hacker community, that they create so many parallel requests, concurrent request, and then they send it to particular cluster, a particular server, right? And they those what happens is, with those so many concurrent, let's say 10,000 concurrent requests are coming to your website, and you don't have any bandwidth, or you don't have any VM or infrastructure ready to cater this much of service, right? this much of request it cannot be served, then what will happen? Your website will get hanged, right? And hackers will keep on doing this until and unless the entire web application is down, right? So that's where you need certain security aspect there to guard and deny these kind of requests. Okay, so this Cloud Armor helps you to do the same thing. Okay, so this is a Google service, okay, to restrict or stop the um, malicious attacks on your network itself, right? So basically, the same service is being used by even Google internal products like search engine. Search engine also uses Cloud Armor. Google Map also uses, and YouTube also uses the Cloud Armor. Okay, so how does it works using cider range. So you can put allow list or deny list. It's very similar to firewall rules, okay, but it's a dedicatedly created for any such things like fake request also. Okay, so it has lot of other policies that you can create, okay, in Cloud Armor. Again, this is another paid service, okay, but how does it work is, let's say this, right? In this particular diagram, if you understand, okay, so here is the Cloud Armor. Let's understand the Cloud Armor first. Okay, we are saying allow the list from this cider range. You know that this particular my web application is being served for this particular region or this particular type of IP addresses. Then you can set this to allow list, or you can set deny list also. Okay, so you can give a particular deny list and you are giving a cider range, right? So what happens is this sits within with your load balancer. Okay, this sits with your load balancer, and then if Armor allows it, then load balancer will send it to the, I think typically it should be like this. Okay, so then it will allow the load balancer to either send it to respective backend, right? Depending upon the load, it is then responsibility of the load balancer. But now the topic for discussion is whether to allow it or not. That will be taken care by Cloud Armor, right? And Cloud Armor has some policy. Okay, as per this particular sample policy, allow the list from this IP address range, right? So now if you're coming from San Francisco region and the IP address is 50.1.1.5, which matches with this particular cider range, right? So it has /16, right? So typically it will have around 65,000 IP addresses, I think it should have, right? So this IP address is one of them. That's why it will be allowed. This IP address, Shane is sitting in Singapore, right? This guy is also in allowed list, so it will also be allowed, right? But if you see somebody is sitting somewhere else, or it can be anywhere in the world, but the IP address is something else which is not in the allowed list, right? It is 120 dot something, right? So it's not allowed. So this particular Cloud Armor will assume that this is something unexpected traffic that is coming in, and it will stop at network layer itself, right? This is your VPC. It's not even going to the load balancer, it is stopped at your VPC layer itself, right? So that's nothing but your Cloud Armor. Cloud Armor will stop any fake request, any siege kind of attacks, any DDoS kind of attacks from happening on your web application, right? um, and what is CDN? CDN is basically oh, I am sorry, this will, okay, this way it will disturb. Let me cut paste or here. Okay, so what is this? This is content delivery network. You remember I talked about edge locations, or this is also called as point of presence locations, right? So what happens is, and let me check. Yeah, let's understand this quickly using diagram. That will be faster. So similarly, that we have seen for Cloud Armor, let's say the similar thing. Cloud CDN also works along with your load balancer. Okay, it attaches to your load balancer. Then what it does is, let's say there are one user is in San Francisco, another user is LA, and another user is in New York, right? So what happens? I mean, just an example I'm telling you. Let's say your POP location, right? POP location means the CDN location is in San Francisco. Then what happens is the traffic goes to the CDN location. Okay, the CDN service. CDN service stores something. I mean, those contents with it. Okay, first it checks whether I have the contents to serve directly from myself or not. Okay, so CDN works on something called as cache. Okay, so caching is nothing but you have your local store. Okay, the contents first are checked whether I can serve from my local database or not, local cache or not, right? So let's say a user is asking for some, some web page. If that web page is cached at this particular POP location, CDN, in CDN, right? Then that will be directly served from there. It does not even go to load balancer. It does not even go to the backend, right? It doesn't go even this particular service will be directly served from here. Okay, so that way your round trip of your request has been eliminated, right? It will go here, then this will respond, then this will go back, right? These all been eliminated. These are all eliminated, right? So that's what is called as cache hit. Okay, it is called as cache hit. That means your content, the requested content are served, are found and served from the CDN itself. Okay, cache miss is the requested content is not found at CDN, so the so it so we can say it is forwarded to load balancer, balancer and backend. Load balancer will send it to backend, of course, but so basically, if in case of cache miss, it will not be able to serve from CDN, and it will send to the load balancer. How it is helpful? So let's say for the first time you get a cache miss, but the next time if there is any similar request coming in, then it will be served directly from your CDN. Okay, so that way the user experience will be enhanced, right? User experience will be enhanced because of low response time. So that's the basically the beauty. This typically is being used by almost all the products of Google, including like YouTube, right? You see a flawless experience, right? Because if that particular video is being rendered from that particular region multiple times, these POP locations will have the contents of that video. It will not even hit the YouTube server. It will be directly cached out from your CDN location itself, right? So let's say for another user, there is a cache miss, then it will go to load balancer, then load balancer will send it to the backend, and then backend will serve that particular request. That will be your normal use case, right? So that's about the CDN. and we already discussed about the cloud armor. These are some attaching points to your load balancer. That's why I covered over here, right? So if there are any questions, then let me know. Otherwise, um, we'll start with the demo on the this one. For demo, let me copy this first. This is going to be again big demo and confusing demo. So let's make the plan first. HTTP load balancer plan demo. Let's say demo plan. I'll explain you first on the diagram what we'll do, and then we'll do the demo. Can any CDN be used? It is automatically taken care there. Once you just need to enable the CDN. You don't have to select any CDN. Okay, CDN is an internal one. Just when you configure your load balancer, you just need to enable that with a check, and you just need to select a particular category, what type of caching you want, right? And based on that, it will automatically be taken care. Infrastructure and its own CDN like Amazon CloudFront. I need to check what Amazon CloudFront, but I'll check. Yeah. How do you know from URL that the request served from CDN or not? You don't need to. That's why CDN is there, right? You don't need to understand whether it is served from CDN or not. If you don't want that to be served from CDN, while enabling the CDN, either you can disable the CDN itself, or you can enable the CDN and set a different type of caching. So you can say there are multiple types basically. I don't want to confuse directly on the theory, that's why I did not cover yet, but I'll show you in the demo. But you really typically don't need to categorize whether it is from CDN or not. Covers caching and any cache, but still changes don't reflect. Sometimes we may change clear cache, but still don't. So you need to check whether the request is from CDN. Okay, so DS. Okay, so if you do not want to trust on CDN, you want certain type of traffic to be always validated against your backend. Then that's what I mentioned. When you enable it, you can select what type of content, what type of traffic you want to be on CDN, or you can select CDN type. One of the type is to validate. When you select that particular type of CDN caching, it will not cache, or it will first validate your request coming from your backend. It will check with the cached content. If it is same, then only it will serve, else it will not serve. Okay, but I don't know any other way to categorize whether it served from the CDN or not. Maybe it's a question at the web application layer or the REST APIs that you decide. Maybe that, but I am not aware whether you can really check whether it is served from CDN or it is served from the server. Okay. So now coming back to the actual topic, load balancer, right? So in demo, I'll be doing, first of all, we have done the template we have already created. We need a template to create the MIG. We have done that already, right? Then we need MIG, right? So basically, this is one this MIG we have already created in the same region, US East 1. Similarly, I'll create one more. Okay, so that will be my second step. First step is already done. Second step we will do. For this one, I'll create one more template. That's fine. For this one, I'll create this also. So one template here. And second, I'll create the MIG. Then, if you have seen, right, we are not able to access the website first, right? So for that, it is basically a firewall issue, right? We have not allowed the HTTP traffic yet. That's why we are not able to get any response on my this particular IP address, even though it is an external one, right? And I have a website hosted already, but it's not responding because I don't have a HTTP firewall. So I will create this one. This will be my third step. HTTP firewall rule. Then VPC we already have. We'll use the default only, so we don't need to create this. Then we'll actually start with the load balancer. We'll start configuring this. So since we have two backends, this is B1 backend, this is B2, right? So we will create backend service. Okay, this is 4.1. The first point we'll create is what I can say, load balancer. This is the load balancer from here. So 4.1 would be my backend service, right? I will configure them. Then I will also attach health check to it. So health check will attach. We already have one health check, right? Created. So we'll remove this from MIG and we'll attach it to the load balancer. Okay. Once we get that, we will get an IP address. This we can even select our own, or we will get that automatically also. Okay. Once this is done, we will create one VM like this. So this is point number 6. Here point number 6 will be VM. Sorry, 1 second. It will be VM. Okay. And from this VM, we'll hit this particular IP. Okay. And let's try to do one more thing is, let's do stress testing. Okay. Or I'll just park this. Okay. For some time. First of all, we'll see whether when we send the particular traffic to this particular IP of the load balancer, once everything is done from UI, I will hit from browser, I'll hit this particular IP, and I'm going to expect that either this, sometimes this will be served from here, sometimes this will be served from here, let's say, right? We'll see if that happens. Um, if not, if doesn't happen, because what happens is, in browser manually I'm only the one who is going to hit this, right? And it will be, I cannot be as fast as that, right? In a typical world, right? A typical website, right? So I can just click on refresh, right? That's all what I can do. But if my VM, so by default, as I said, right, by default the request will go to the nearest location. By default it will go to the nearest region, right? So let's say if I am sitting in India, it will go to either US East or Europe, whatever is the nearest. By default it will keep on going to that one, right? So for that, we'll see if it goes to the randomly, then we can conclude that this load balancer is working fine. If not, then I wanted to do some stress testing, but then that will require some more time. What I'm going to do is, in one of the VM, I am going to do some a stress on that particular. I'm going to create multiple concurrent request. I'm going to load this particular one MIG, so that it will load balancer will start sending the uh, request to the next closest region. Okay, I hope this plan is clear now. And then according to the plan, let's get started. So first of all, my website is not working, right? My template is there, my MIG is there, but because of the firewall rule, I've not allowed the HTTP traffic yet, right? So for that, let me go to VPC network and then firewall rule. Let me create one. So do we have any allow HTTP? Fine, that's okay. I'll create one. Allow HTTP. I want to be applied to default network. Yeah. Priority ingress allow specified network tags. So this is the beauty. We had in the previous demo when we checked the firewall rules, right? I had created that for all the instances in the network. Okay. But whereas if you see here, we have multiple other options also. As I think I had given an example of a volunteer t-shirt, right? It's like a tag on your t-shirt, so that you can simply identify on whom I want to apply this particular rule. Rule is like announcement, you can say, right? So this firewall rule will be only applied on, let's say, target tags who are having the target tags of HTTP server. Okay, so this is just like a tag I am attaching. I'm telling this firewall rule to check any resource, VM or cluster or anything, whoever has this particular tag, then check for this particular rule, firewall rule. So if you see here, um, in my instance template, let's not open, yeah, let me open the instance template meanwhile, and meanwhile, let this be traffic coming from anywhere. So 0.0.0.0/0, and I want to allow TCP/AT traffic, right? HTTP traffic, and then I say create. So if you see here, the target tag is HTTP-server. Okay, so let's say this template. If I show you this particular network tag, I have attached to the template. That means whatever the VMs that we are creating, they will also have this tag, and my firewall rules will be applied on those, because I say that okay, so whatever are the uh, resources, whatever the VMs with that particular tag, check against this particular firewall rule, because the tags match, right? The tags match. That's why it will be first checked. Now if I check this, it should be able to, yeah. So if you see here, now we have fixed that issue, that I am able to use HTTP traffic to my VM. So my VM, let's say, let me go back to this MIG, and let me check the other one as well. I have hit this one, right? Let me check the other one as well. The other one is also responding with the website. So this is nothing but the code that this PHP files content that I'm getting here. But what is happening is, if you see here on this particular page, I have customized in my code, I have customized to print the region. Okay. So what happens is, this region is, if you see here, this region is different, this region is different. Okay. Why? Because it is being, these are the two different VMs, right? This particular VM is in C, this particular region is in D, right? So now if I individual, what I'm doing is I'm individually checking the IP address of that particular VM. That's why I'm getting that response. But typically this is not what we want in load balancer, right? We want a load balancer on top of this MIG, right? We want a load balancer on top of my backend. I want a load balancer. I want this IP to be hit, not the IP of compute engine, right? So right now, I'm just for the testing purpose, I'm just checking whether my VMs are responding or not, right? So that's why I checked. But these are not the IPs that I'll be using. I'll be using the IP address of the load balancer, which we have not created yet, right? So for that, now let me just create one more template. So this part is fixed now. Okay, the third part we have already fixed, but the template, because I want two backends, we have only created one MIG, one backend. This one will create another template, and MIG number two now. So what was the region? Europe West one. So let's create in Europe West one more template. Pay attention, guys. This could be a little tricky to understand. So Europe West one template, and I will say simple machine and one micro. Let me close this. If needed, I'll open, but I don't know. My machine goes for a toss. So N1 F1 micro one. I'll be little faster this time. Advanced. In advance, I'll also attach the same network tag, so that whatever the machines get created will also have this tag, and my firewall rule will allow the HTTP traffic on that. And then this time I will select the Europe. What was that? Europe West 1 or 2? West 1. Did I miss it? Yeah, Europe West 1. Fine. Let's keep the external IP just to check. Okay, we are not going to use these one external IP of that particular VM. Management, here we had added that um, startup script, remember? So let me get that. Okay, that's the key name and that's the value. Okay, so this is the open, again this is the same shell script that I explained you. This will install the web application that I just showed you on the simple web application that will install on the VMs that are created using this particular template. Till now we are not created any VMs using that, but now let's create a instance group out of this. So one of the ways to go and select that, other one is just select and say create instance group. Okay, let me try this. So it will land up on this particular page itself, and I'll say Europe West 1 MIG. Then multi-region. This is also multi-zone, sorry. And then I want this to be in Europe West 1, Belgium. Yeah, this template, yes. Distribution, add minimum to maximum 5. I don't want more than 5 VMs. CPU utilization, I'm just keeping that as 40. So if CPU utilization of any of the VM goes for 40, it will start adding new node. No node means VMs. Okay, it will start adding new VMs to my MIG. Okay, cooldown, just wait for 45 before it starts serving the traffic. Health check, I will not be attaching to this particular instance group. I will be attaching to the load balancer. We are just creating two backends now, right? This is there, this is we are creating. We have not yet started the load balancer. So we are just creating two backends. So okay, leave it. And is there anything else? Okay, let's create the MIG. Yeah, I mean, I'm not from that background, basically, but yes, I mean, I understand the URL response headers, which typically you can get. So yeah, maybe that you can look for your question, right? Mm, okay, so now if you see here, this particular MI is also. So we have two backends ready here, and let me remove the health check from the first one. It's not typically required, but anyway, I'm going to attach that to the load balancer. That's why I'm removing from MIG. But you can keep it at both places also. That's also fine. Okay, now let's start with the updating. Let it update. Also, before going to the load balancer, let me. So, is it fine that if I skip the I don't want to break the flow, right? So is it okay if we break out after the demo? Otherwise, again, it will not make sense for you guys. That's why I'm requesting. Okay, thank you. Thank you. Um, okay, so here, this is the another MIG, right? Let's check this also. Okay, this is also responding. It basically responds with the host name of from where this particular response came in, right? So if you see, this is the same host name of this machine and also the zone, right? The same zone. This is again West D, right? So let me open that, and it says NC3Z, right? So NC3Z, right? So basically, I'm getting the similar response from all the website, but the thing that I need to check is which VM. VM is the host name. Which VM has responded to me? Since I am hitting that IP address of that respective IP address of that respective VM, I am going to get that. But when I have a load balancer in front of them, then load balancer will either send it to these two or the other two, right? So we have four instances to serve our request, so it can randomly go to any of those four, and that's where I'm going to expect and I'm going to check which host has given me the response. Sometimes then again I'll refresh the web browser, it might happen that it will be served from another one, right? So that's what, for that we need to have a load balancer in front of this backend. So now these B1 and B2 are done, templates are also done, and HTTP firewall is also open. That's why I'm able to access the website on the browser. Now we need the fourth point, that is the load balancer. So now let's create a load balancer. For that, just search for the load balancer. It will be in network services. Some category will be there. Yeah, network services. You will find it here, but just I'll go from here. Load balancing. Okay, click on load balancer, and now you will land up on this one, this page, right? So now we are working for HTTPS load balancing, right? So let's, similarly you have other one as well, but for now we'll go with the configuration of the HTTPS load balancer. Now what type of load balancer you want? External one? So yes, I want an external one. Do you want a global? So we have two under global. One is classic. I think this is typically changed now. So as I said, right, the Google Cloud is keep on adding new things. So maybe classic is the one does not support advanced traffic. I think classic is the old one. In previous batch, I did not had this option. So okay, let's go with the classic. Maybe some advanced traffic management feature. Okay, not sure. So okay, we'll explore that one later. But for now, we'll go with the classic global. Okay, so global and external, right? So this combination will go with. Now it is asking for a name of my load balancer. It can be anything. Okay. Then front end. So basically front end is nothing but your load balancer, right? So in your case, if you see here, this is your front end, this is your back end. Back end is nothing but MIG. Front end is nothing but a front, I mean, this particular IP that will be public facing, right? So that is your front end. So what is that you want to be? So I want to be a HTTP front end, right? So I'll be using ephemeral, that's okay. And I want 80 port. I don't want 80 ports by default. So that's okay. Can we go to the backend? Yes. So let's mark it as done and then go to backend. Now here is what you have to attach the backend, these two backends to your load balancer, right? So I'm going to say create a backend service. Okay. Now in the backend service, I can say, can give again name of my backend, any name I can give. The type, what type of backend do you want? I want instance group. There can be another types also, but I want instance group. This is my MIG, right? And what type of traffic will go? So I will go with the HTTP and timeout 30. We'll go with that. Now here is where you want to give the instance group. You have selected instance group, so it is asking me which instance group I want to attach to this load balancer. I need both of them, right? So I'll have to add two backends. First of all, I'll add this one. What is the traffic? I'll go with the port 80. Then I said, right, utilization from load balancer perspective, what type of load balancing mode that you want. So I want, let's say there are two options. Utilization is how much traffic you are getting at the load balancer. right? Not at MIG. MIG, utilization we have set it to 40%, right? CPU utilization 40%, you remember. But here at the load balancer level, let's say I go with the rate. So rate is nothing but how many requests I want this particular load balancer to support. Let's say if I set it to 30, so 30 requests per second per instance is my capacity that I am setting. Okay, so what happens is this particular MIG will be serving the traffic if there are 30 RPS, if it is under 30 RPS, right? So 30 requests per second, which I cannot manually do, right, from browser. I maximum what I can do is start hitting refresh and refresh every time, but this will not create 30 requests per second, right? So but we'll go with that. Let's see if randomly it will at least select the two of the region, one of the region. So utilization is again similar to CPU utilization. You need to provide some percentage, and then depending upon that percentage, it will select the particular backend. Okay, so now I'm selecting one. So I have added one backend here. Now I can add one more backend. So add backend instance group. I can select the another one this time, and I can say yes, port 80, rate same 30, and I can say yep, done. So I have two backends attaching to this load balancer now. Okay, then Cloud CDN, either we can enable or disable it, but I want it to be disabled because for the demo I want it to go to this backend, right? So I want this every request to go to the backend. If I keep CDN on, it might be served from my cache location only, right? So it will start showing me the same response, right? So that's where in this particular case I want to disable CDN because I want every request to go to either of these particular VMs randomly, right? That's why I'm disabling the CDN. But Dia had asked this question, I think. Yep. So you can say cache the static contents. If it is static, then only it will cache. Force cache all. So if you can select these things, right? No cache. You see here, if you specify no cache, skim, then from your web browser, right? So it is then from the client side, when you say that I don't want to cache this, then it will automatically check for this particular request headers in the value in the request header, and it will always go for your backend. So you can control that, but in our case we'll just disable this. We want every request to go to backend without caching, right? So health check, as I said, right, we can attach the health check here. Then you can enable the logging. This will go to, it will add more logs, but that's okay. And if you see here the armor, you can attach armor also, but for simplicity we'll go without that. Is there anything else that we, I think that's it. Let's create. So it has created a backend service, and this backend service is connected to two MIGs. One is in US East 1, and just pay attention to this region also. US East 1, another one is Europe West 1, right? Just remember this. Two backend MIGs are connected to this service, and I'm just saying okay. So this is one of the, it says, right, two MIGs are in the backend. Then let's go to the next one. Is there anything else? No. Review and finalize. So here you can see front end, some IP address that will get generated automatically, and in the backend you have two MIGs, right? And these are the balancing mode, and these MIGs has auto scaling based on this CPU utilization also, right? And that's it. They will be able to communicate on port 80, that is HTTP. Let's say create. This might take a while to set up. Meanwhile, we'll come to this. I'll show you this one. But meanwhile, I don't want to waste time. This particular forwarding rule, proxy, URL map, these are already taken care automatically. Health check we have attached. Anycast IP, this will be automatically generated once this load balancer is up and running now. This is still getting created, right? Now one more thing is we need this sixth point. We need a VM, right? So meanwhile let's go to VM instances. In another window I'll create one VM. From that VM, if needed, we can do some stress testing, but for now I can also use the browser. Okay, so create instance. Okay, it's a client VM, right? This is a client VM. So I'm going to create that in US West 4. Okay, if you see this, we have MIGs in US East 1 and Europe West 1. But I'm going to create one VM near to this region, right? So it's in the same continent, right? So we'll create in the US region itself. So, but it is in a different region, US West 4. Okay. So for this VM, any traffic coming from this particular VM, for what will be the nearest MIG for that? This will be the nearest MIG, correct? Because this is nearest to that in the same US region, right? So, so for this default is fine. I don't want to expose this as a, I mean, create this as a web observer. So don't want any startup script, anything. I'm just thinking, do I need anything else? Okay, let's create this VM also meanwhile. Let me go back to the load balancer. If you see here, load balancer is uh, up now. There is an IP address. Let me try to hit this. Okay, it might take a while. Okay, we'll have to wait for 2-3 minutes for this load balancer to come up. Okay, so what will happen is once I hit the IP address in, this is the Anycast IP that we were talking about. Once we start hitting this from the web browser, it will forward this traffic to either this and this, right? So it will be random, but it will try to go to the closest region, because to save the, the, for the low latency, for the faster response, it will try to go to the uh, uh, closest region by default. But let's see. uh, Meanwhile we have a client VM. So what I'm doing on the client VM is, if from the browser, if that keeps on going to the same, what happens is, it might happen from the browser. What happens is, since my browser, I'm sitting in India, I have a same IP from where I'm sending. So based on my IP and my location, it might happen that this particular load balancer will keep on sending the request only to this region, because this is, let's say, example I'm saying, it can be one of them, or it can send this also, but this is random behavior, right? So if I don't see that from the browser, that in none of the requests are going here, then what I can do, I can make some attack here. Not attack, I mean basically huge number of concurrent requests I can send to this. I can make it overloaded, just like hackers do, right? This particular one, so that my load balancer will, okay, will see that, okay, this particular MIG is sitting idle, so let it send it here now, right? So then it will start sending the traffic here. It has to, right? Then that is what the load balancer is all about, right? If this is overloaded, then send it to this one. If it is not overloaded, select the closest one, right? So if my browser does not send randomly, then I'm going to do this. And for sending these concurrent requests, I need this VM. I need some stress testing tool also. Okay, that stress testing tool is called as Siege. Okay, so I'm going to install Siege on that VM. So how do we install any tool? Right, we go to SSH. This is only if this is conditional, okay? So I'm just making this machine ready if in case we need it. Meanwhile, let me check. Okay, so now my load balancer, this is the IP address of my load balancer. Even I can give this to you guys and you can try out. Okay, so you can start hitting this and let's see. So, but pay attention to my screen for some time. If you see here, we have these four instances. Okay, these are part of US. This is one MIG, this is one MIG, another MIG, right? So what happens now if you see this diagram particularly? uh, this diagram, one second. Yeah, so now these two VMs are here, two VMs are here now, and the IP address which I gave you is the Anycast IP. Now this can get to any of the VMs. Let's see if it happens, then good, we are good. So here just keep an eye on this one and this one, majorly this one. So if this keeps on changing, then we are good. So now if you see here W74W, right? So that's the this particular response I got from this particular VM, right? Now let me rephrase this. Okay, now if you see here, it came from XCG0. So now the response came from another VM, right? So you can say, I mean, the load balancer is sending the request to the VMs, at least to the VMs. Uh, Let me see if it is going to another region or not. But if you see here, for this, you can also do one more thing. 1 minute. I have an extension. So let me hit it from this, and I have an extension here. Auto refresh extension. You can simply get it from Chrome Store. What this will do is every 2 seconds, it will keep on refreshing my web page. So typically, so this is why. Okay, so if you see here, this is getting changed. But if you see here, this is still going to the US East one only. Okay, this is using the VMs of my US East one, because from my laptop, US East one region is the closest. None of the traffic is going to US West one yet, right? Let's see it again. No, it's not going. So it's just balancing the load between the US East one. Why? Because it's not reaching to that 30 RPS, right? That are what we have set, right? So unless and until we create that much of load, unless and until we create too much load on this particular US East one, Europe West one will be sitting idle, right? Because right now I'm the only hitting, or maybe some of you guys are also hitting, but it's not reaching to 30 RPS, right? So for that, what I'm going to do is we already have a VM, right? What we are going to do is we are going to do some stress testing on this particular load balancer. For that, I logged into this particular VM. Okay. So meanwhile, if you any one of you are also hitting, let me know if you see US West. Sorry, not Europe West. But now let's do the rest of the stress testing. I would say we'll have to do. Okay, so now, okay, so here sudo app get update. Okay, let me update all the binaries first. It's done. Now let me install Siege. It's one of the tool. Okay, this tool helps us to create concurrent request. Okay, so what will happen is, let me type that command, siege -c 250 150, yes, and then http, and then the IP address of my load balancer. This is the IP address of my load balancer, right? Okay. It automatically took 28. Okay. So what is it is going to do is it is going to create 250 concurrent request to my load balancer and let it load. Now what will happen is by default they all will go to the nearest region. What is the nearest region? This VM is in US West 4. You remember it was created in US West 4. So the nearest location will be US East 1. So all the traffic from this VM from this particular request will go. First of all, it will try to overload the US East 1 MIG. US East 1 MIG because it is closest one. So load balancer will try to send it to US East 1. Now, since we are sending so many requests per second, right? So that will get overloaded hopefully, and then load balancer has to send it to Europe West 1, which is sitting ideal right now. So so that's where we and then we will see my request also because US East 1 MIG is overloaded by the siege attack. So even my request from my laptop will also should go to Europe West 1. Okay, so let's hit this. We'll see. Okay, so it is running the siege attack. Okay, we'll also go to the load balancer and we can go to monitoring. Here is the we might be able to see the traffic in some time. Okay, let's wait for some time. I meanwhile I also have the not this one. I also have this one auto refresh. So I still see everything is going to US East 1, always US East 1. So but yes, the VMs are changing within the East 1, but it's still going to the US East 1, the same MIG, right? So that's what now we'll just wait for some time. Okay, so it's still sending all those. Let's go to monitoring. Yeah, so now if you see here, some traffic is coming from Asia, some traffic is coming from here, and backend service. Let's see if you can click on view details, it will show you advanced configurations. It will show you, yeah, there is a spike, not spike, but it is just 2 RPS on this. Let's see. Let's wait for some more time, and we'll have to keep an eye on this also. In monitoring, I'm just trying to check whether I have a good amount of traffic. Okay, so this is coming from my VM. You remember we have a VM. Very big traffic is coming from America region, US West 4 region, siege. So let's see. Traffic. We'll see. Yeah, you see here 200 RPS. It reached to 200 RPS. Hopefully now we'll see. You see here, right? So now the US West 1 MIG, which was the closest, is already overloaded with 200 RPS, and the criteria was 30 RPS, right? So that's why it now it is going to Europe West 1 because that was sitting idle for all this time, right? Now it is going to Europe West 1. I hope this is clear. This is why I wanted to create a 250 request per second, right? So now the siege attack is also over. All those 250 requests are done. So now I mean still those are getting processed. Now if you see here, those are random now. US East 1, sometime it is Europe, and after some time again, once the all the requests are over, right? So then again, by default, the traffic will start going to the nearest one, right? Because now the siege attack is done. So typically my US East one, which was overloaded, will now be not that much overloaded. So then my see now the traffic is reducing, and if you see here again, every request is now getting served by the East one, US East one. Okay, got the Europe. Okay, 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 perfect. That you guys are also trying. You got the Europe as well. Okay, that's all about the load balancer. Any questions on HTTP load balancer? We have lot of other things to cover. Okay, so let me just close this and we'll delete this at the end of the class. Just make sure if you try okay this demo, then delete the load balancer, delete the MIG, delete the VMs, not just the VMs, delete the MIG, because these VMs are managed by MIG. If you delete the VM, this MIG will again create it because it has auto healing, right? So it will again create it. So don't delete the VMs and leave it. Delete the instance group. Okay. Now coming back to this, I will clean all these resources later. Okay. But let's go back. Let me see. So we have done all this HTTPS external load balancer we have seen. We have other things. Okay. I'm going to explain you the architectures of each of them. Okay. And I'm going to give you the homework also. Okay. Um, so first understand the architecture of rest of them. So this is again going to be a little bit theory part now. So let me see. First one is SSL. We can cover SSL and TCP proxy load balancers. Okay. Let me take up the question if there are any. I don't see any questions. Okay. So for HTTP, sorry, sir, SSL, right? So for SSL also, I think we have a diagram. Yeah. So let me paste that diagram. Okay. Then let me did here. Okay. So basically, if your need is not for the web application, let's say it's not that you always have a web application and then only you need load balancer. No, it's basically you're on for all your network traffic, right? So the first load balancer that we have discussed so far was HTTP load balancer. That's why we needed browser. That's why we needed web application. We needed website, right, on that VM. But what if your traffic does not even require any website, but you might get a you have a backend and you have some code written on it and you need to respond via a JSON response or something like that, right? So if you don't want that kind of you don't want website to host, but you still want a load balancing at the network side, that's where these rest of the load balancer work. They work at network layer, works at network layer and not at the application layer, right? So network layer, or we can say transport layer. Okay. So these load balancer, SSL proxy or TCP proxy load balancer, UDP load balancer, all these load balancer works at network layer, not at the application layer. Okay. Now if your need is a non HTTP, of course I just wanted to write it down, that you are not expecting an HTTP traffic. You are expecting some SSL or TCP. I'm covering both of them here itself because those are very similar. Just the port and the request type of request that it will use in the connection will be different. Okay, so it is not going to be a HTTP traffic, so it is non HTTP traffic. And in case of SSL, it is encrypted SSL traffic. For SSL, okay, so let me write it this way. So for SSL load balancer, okay, it works at network layer. It works on non HTTP traffic, and since it is SSL, it will be an encrypted traffic. Okay, it will be encrypted, so the traffic which will flow on your network will be in encrypted way. Okay, again, this is a proxy, right? It's a proxy load balancer. So if you see here in this particular diagram, right, it will terminate the connection at this particular proxy level. Okay, this is entirely from here onwards, it is your load balancer. Okay, the internal architecture is just like this particular architecture which I explained in the HTTP. But what will be the change? The change will be that it will be SSL traffic. It is going to be an SSL traffic. SSL traffic works on this particular port again, right? 443. So SSL traffic will be encrypted, and again this will be encrypted as well, right? But this will be terminated as it is using the proxy. This particular IP, if a user is there here, if user is there here, the IP address of the user will not be I mean it will not be sent to the backend. So and the other way around also, the IP addresses of this particular thing will not be sent back to the final response. The SSL proxy will close that particular connection at that level, proxy level, and it will create a new connection. So if you see here on the left side, right, connection 1 and connection 2, so it will create a new connection all the time to the backend, right? So new connection will be created without the client IP. Okay, so this is also called as SSL offload. Okay, uses 443 port. Okay, then intelligent routing. Okay, this is one important point for this is intelligent routing. So what happens is any load balancer typically has different algorithms. These are just for your general knowledge. No questions will be asked like this. Different algorithms. It's like round robin. Everyone would be aware about that. So round robin means go first request to the first one, second to second, third to third, and then fourth to the first one again, right? So in a round robin fashion, the request will be served by the underlying resources or the VMs, right? Another one can be lowest response time. Response time, right? So whichever VM or whichever MIG gives me the lowest response time, it will automatically elect that particular MIG for the request. So it will start sending to that. Let's say response time has increased. So then it will switch back to the another MIG, and that will get, elect uh, who is going to serve the traffic. That will be keep on switching based on the response time. Simple. Then sometimes it can be lowest CPU utilization. Whichever MIG is having lowest CPU utilization, that will be elected to serve the traffic. So all these algorithms are there as part of the load balancer, which will be taken by SSL load balancer to select the particular MIG, right? Then of course security patching and all these things will be taken care. Google GCP will take care. Okay, so all you need to understand here is that this is not a application layer protocol, so it will be like network layer, so it will be all at the packet level. Because of that, we will not be able to see anything on the UI. Okay, but this will happen, or this traffic will be routed on the port 443. Okay. Similarly, in case of TCP, the only change would be TCP LB. This will be exactly same. Okay, all same. I would not write all those down. Same as SSL, except below points. Let's say except this will use 110 port. Okay, traffic will be non-HTTP but non-encrypted. The SSL traffic is encrypted because of the SSL certificates, but TCP traffic will not be encrypted in this case, right? Again, proxy will be same. So proxy, it is again a proxy load balancer. Let me write it here, proxy word, so that it's a proxy load balancer. TCP is also a proxy load balancer, so it will also terminate that connection, but it will not be creating encryption on top of your request. Okay, that is the only change. Mm, Again, you can deploy this at global. This is also same as that, so I don't want to include that here. Anything else? Again, this also, and this can be external also. Okay, it can be external, doesn't mean that it has to be a web application. External means the traffic can come from outside GCP also. Using the IP address, you can get the packets inside the network, and it will always work at the network layer. Both of them, just that the port and the request types will be different. It will be encrypted and non-encrypted respectively. Okay, this is all about SSL and uh, TCP proxy. Then we also have something called as internal, right? uh, Internal load balancer. So sorry, HTTP, internal HTTP load balancer, or HTTP, or HTTPS. It should be, or internal load balancer. Okay. So so far the HTTPS or HTTP load balancer that we have seen was an external one, right? It was internet facing. You can also have internal load balancer of type HTTP. So what happens? How does it look is I have a diagram for that as well. Okay, I'll explain you this. This you might find common in your project also. Okay, so this is clear about the external HTTP load balancer, right? So now let's see, in the same diagram we have both of them, so it will be easy for you to understand also. So if you see here, there are multiple requests coming. You have an external load balancer. This is what we already demoed just now. Okay, so port 80 will this will select this is the external load balancer on port 80. Okay, now if you see here okay, let me just check it. Okay, so this is a Asia, this is another MIG, this is one more MIG, this is one more MIG, right? So depending upon the external request, one of the MIG will be selected. One of the MIG will be selected, either this one or this one or this one. Okay, that we have already demoed. But now let's see, you have a web application. Since it's an HTTP, now I'll be talking about web application, the website. How a typical web app looks like is, let's say you have a website. Okay, you deploy that on a VM. Then you have a database. Okay, this is your web tier. Then you have a database tier. You have a database that is also you are deploying on another VM. Then you have a backend business logic. Okay, business tier. So that has to take the take the request from web tier, process something, get the data from database, and process something, and then send back to web tier, right? So this is also again another on deployed on another VM. Similarly, let's say for a web application you have 3 VMs serving different tasks. right? So that's the exact thing that have been shown here. There is a database tier, there is an internal tier for the business logic or the backend logic, and then you have a web application deployed on another VM, right? So now if you have entire these three things, okay, all these three VMs are in one MIG only, always, and you don't have any control, let's say. So what happens is, whenever there is a external load balancer will do its task, external load balancer will send that to one of the MIG, but what will happen is all the web application request will be served from only same backend and will also be sent to the same database tier. So this database, let's say this was elected by the external load balancer. Now internally this particular backend or the database will be overloaded. This database will be overloaded, right? So all the requests will come to this particular database only, even though those are replicas, but it will be served by the only that particular VM, right? So this way the database might get overloaded. So that is where you have something called as internal load balancer. So what you can do is you can deploy the internal load balancer at a regional level. Okay, this is a regional one, regional. So what will happen is, let's say this is another zone 1 and zone 2. Doesn't matter that where this external load balancer has sent a request to. Okay, what will happen is you can tie up to that particular IP of your internal load balancer and let it internally distribute your load to the different database. Okay, so it can be database 2, it can be DB1, right? So that is the exact same thing that has been explained over here. So depending upon whatever request you got from the external load balancer, you can further distribute that to your zones also, right? Because internal load balancer is HTTP load balancer is running at a regional level. So if you see here, the region is same. It is US Central 1, but inside that it's a -A and it is -B, right? So it's a in zonal you have multiple control on the zones within the same region. This is the entirely is the same region. I hope this is clear. This is how the internal load balancer works, HTTP load balancer. So, and this HTTP, since it is an HTTP load balancer, it will, this particular communication between web tier and the load balancer will again happen using the HTTP traffic on port 80. Okay. So, but it will be an internal one. So at the regional level, and this will not be public facing. So this IP address will be an internal IP address. It will not be a public facing IP address. Will be used by your application within itself. Okay. So that's again architecture of the HTTP internal load balancer. Then we have something called as regional load balancer type, right? So regional load balancer. So this is based on the deployment mode that I was talking about, where it is deployed. This particular load balancer is deployed within a region. That's why it is also a regional. So this also can be HTTP or HTTPS can be a regional, right? This can be regional, internal. Internal, don't confuse these two terminologies. Internal means whether the traffic is coming from outside to this load balancer. No. So this is internal. But where it is deployed inside a same region, one region. So it is regional. Okay, these two things are different. Don't consider that regional are always internal. Okay, don't consider that regional are always internal. Regional can be external as well. Okay, so under regional, we have certain things. Let me remove this and certain types. So let me specify this. Okay, so one is HTTP regional, okay, and internal. We have just seen this, right? HTTP regional and internal. Then we have TCP or UDP traffic regional. You can deploy that at a regional level, but it can be external. Okay. And then another one also you can deploy at the TCP. You can use TCP UDP traffic regional and internal. So basically I wanted to cover regional part. Regional, under regional load balancer you have these three options. Okay, does not mean, okay, again I'm repeating, regional does not mean internal. Regional can be internal and external both. Okay, now how do you do that? It's basically if you go to the load balancer, let me show you once, and then I'll also explain you the homework demo that I have. Okay. Uh, so when you click on create load balancer, you have multiple other options, right? So if you see here, TCP load balancing, UDP load balancing. If you go back to our discussion, UDP is always regional. You cannot have a global UDP traffic load balancing. So if you see here, UDP has two options. One is internet facing and single region. So it is always a regional one. It can be external. Internet facing is external. Internal is internal to GCP. So it can be an external or internal, but it always has to be a regional. You see here, UDP is always a regional one. You cannot have global UDP load balancer. So if you go here, there is no option to select whether you want multi-region or region. It is always going to be a region. Okay, that you can select later, but on the next, if you continue, it will ask you for the region, but it can only be deployed at regional level. Okay, so the backend service can be again MIG, or there is another option. If you see here, target pool. Target pool is very similar. Again, let me cover that as well. Target pool is very similar to MIG, but you have to add instances. In MIG, you might have seen, right? We have not created those VMs. We just attached one template, instance template to my MIG. I created an MIG and I given input as which template I want to attach. Based on that template, it automatically created those VMs underlying, right? Whereas in target pool, you have to create the instances and you have to add the instances in the pool. Okay, so you have to create instances and then add the instances in the target pool, and then you can use that target pool to attach to your load balancer. Okay, so typically those auto healing, auto scaling will not be possible. Whatever the instances you add, those will be in your target pool, and you can attach the target pool to your load balancer. Okay, so the homework demo that I was talking about has a target pool, and I'll in that one it will create the target pool and it will create the instances. It will add those instances in the target pool, and it will use the target pool instead of the backend service, right? But the point here is for UDP that we have selected, we don't have any global option. We have only regional, so that's why it is always a single region. But if you see in the other one for TCP, right? So if you go for this one, so it can be external and internal, and it can be regional and global. Okay, so if you go on this one, it will ask you whether you want to do it at the global level or if you want to go it at the regional level. You can have a regional and global both in case of TCP. So let's say if I select this one and go continue, so depending upon what type of traffic I want, right? So if I want SSL traffic, right? So I will go for the port. If you see here, so right. So if you see here, I want to use this particular MIG and backend at the backend, but I want traffic to be routed on 443. Okay, so that will use your SSL traffic. Okay, Whereas when you go for the port number, yeah, 443. Okay, when you go for the TCP, it will be 110. All that you have to configure over here. Okay, so that's how, I mean, this part, if you don't recall what I'm trying to, this one, right? So based on your ports, you will have to configure it differently. If you want HTTP, you go with 80 or 8080. Okay, so that's how you configure all these things. Now the load balancer demo. Okay, so for that I think I have already attached one PDF. You can just go and at the very bottom you will find one PDF in your notes, in your batch, in your batch notes, the first bubble. Okay, but again, one more thing, one place I can show you is I have all the net demos here. For homework demos I have here, and you can see a network load balancer. So you can create a network load balancer using this demo. Okay, somebody had also asked me in the previous one that for the VPN it was very confusing, right? So I had given a cloud shell PDF, but I also have a steps how to create a VPN, high available HA VPN using UI also. I don't have screenshot. I have a table. You just have to, you know, you remember we had opened two tabs for two projects, right? One was on-prem project, one was GCP project. So just follow this thing parallelly in two tabs. Created in open two tabs parallelly and then follow these things. So I just recall. That's why I'm just telling you here. This is not related to today's topic. Today's topic demo is this one. So if I open network load balancer, this time everything is G Cloud based. So those who are interested, they can do. Okay. So just set your projects. Just open the Cloud Shell. Okay. Just by going here, just open a Cloud Shell and start following this command. Okay. So run this command, G Cloud auth list. You will see something like this, right? Then follow this. Select any region. So just run uh, this command. So for this demo, Australia, Southeast 1B, Southeast 1, uh, and this region, right? Southeast 1. So declare these two variables so that I have used these variables with dollar sign over here, right? If you see here, so that's where these will be automatically taken up. So just follow this. So I'm creating a web server instance here, create ww1. This is the one VM I'm creating, right? One instance I'm creating. I told you, right? We are going to use target pool in this demo. So we have to create an instance. So similarly here I'm creating ww1, ww, and then I'm installing something on that. ww2, I'm installing something on that. ww3, similarly. Then I'm going to create some firewall to allow the traffic. Then I'm going to create external load. Yeah, so I'm just going to check. This is just to verify if my individual VMs are working fine or not. But this is not the load balancer IP address. Okay, these are the IP address of my VM. So then I'll start with the load balancer. So I'll create one external IP. Okay, in our demo HTTP, we had automatically let it generate the IP address. Here I'm creating an external IP address, and then I'm going to attach that external IP address to my load balancer somewhere in the somewhere later in the steps. Now if you see here, I'm creating a target pool and I'm adding an instance. If you see here, I'm adding instances ww1, 2 and 3 which we created earlier, and then we are also going to create forwarding rules. All these things we are doing one by one, and then once everything is done, um, one sec, forwarding rule, yeah, health check is also we are creating. Okay, and then attaching. Okay, so now once we have that particular IP address of the load balancer, we can simply open Cloud Shell itself. Okay, go to the Cloud Shell and run this particular command. I'm not able to select this. Let me check this, and that's fine. But let me just, it opens. Okay. So here maybe in Edge browser, I'll be able to select what I'm talking about. So all you need to do is again, I'm not able to do this. Fine. So what you need to do is you just go to this Cloud Shell. You will be working in Cloud Shell anyways, right? So what all you need to do is just from this while loop, you need to run it. So what will happen is, what is this is basically it's a loop. Okay, it's an open loop. Okay, and it will start hitting. Just replace this IP address with the IP address that you get when you run this particular command for an external IP. You will get an output, and that address you have to replace. Just remember, don't hit this one. Okay, and then it will start in a loop. What you are interested to look is whether the traffic is getting served from different VMs or not. Okay, if it is coming from WW1, it will print like this, WW1. So if you see here, WW1 2 1 2, then randomly 3 2 3. So you are expecting output to be randomly uh, generated from those target instances from your target pool, right? So you can do this way as well. Okay, so this is a homework for you guys. At the last, you just run these commands. Okay, so that you should be deleting all the resources right from after your demo. So I think that's all. Let me just check one sec. Did we cover all of the things? External, yeah. Choosing the load balancer. If it is okay, I can take up this for 5 minutes. Simple. It's very simple. Again, this will not be, always the case. This is again case by case basis. It will be different. But let me show you what I mean. We have this diagram. Let me go. Choose the right load balancer. Let's say right. Sorry, just 5 more minutes, guys. Not take much time. Okay, so when to choose what, that's all this particular diagram talks about. Okay, this again, you have to ask certain questions in your real projects, right? So whether you want an external one, whether you are creating, whether your application has a web application, whether your project has a web application like a website or something which you want to have a load balancer with, then it's an external one that you have to select, right? Second, what happened? Okay, I'm able to use now. Okay, fine. So let me take a black pen. Something has happened. Okay. So if your traffic is coming from internet, okay, if you are expecting that your web application has a traffic from internet and you want to balance that traffic, then you can go for the external one. Now, as I said, external is nothing but internet facing or internal to internet to GCP. It supports both the type of IP addresses, v4 and v6 both. Then you have option for external one. Now under external one, whether do you want to have the traffic routed for let's say for web application, then you can go for HTTP. If it is a packet level, you don't have any UI or anything which you want to hit on the browser, but it is coming, let's say, from a backend, some other backend to this backend, right? So let's say you have an on-prem here and you are sending one request from code to code, right, without even any UI, right? So it is still an external traffic for me, right? So it can go via TCP, right? It can go via basically non HTTP. So either it will go via TCP, SSL, or UDP, whatever, right? So let's talk about the the HTTP first. So if your traffic is HTTP traffic, then you go for HTTP.
Now under HTTP, whether you want this traffic to be routed, you want to deploy this particular load balancer at one particular region, or you want to have multiple regional MIGs attached to it. Depending upon that, it is called as either external or regional, or it can be called as global, but it is still an external load balancer. External load balancer can be regional, external load balancer can also be global. So deployment mode and balancing mode, do not confuse them with each other. That is a combination that we are talking about. Okay, so if it you want to deploy at a regional level, then it is regional external load balancer. If you want to deploy at multiple regions, then it is global. So you will have two MIGs, three MIGs, multiple MIGs, right? So that's all about the HTTP load balancer. Now your traffic is not HTTP traffic. You do not have a web application, whereas you have some code on your web, let's say on-prem, that you want to communicate with your GCP. Okay, and then you can go for TCP traffic. This works at the network layer, right? So within TCP, if you want this entire traffic within GCP to be encrypted, then you go for, do you want SSL offload? Yes, I want SSL offload. Then go for SSL proxy, because this will use SSL traffic, but a proxy traffic, right? So it will offload the IP address of from where this particular client request is coming from, right? That IP address will be offloaded. Okay, so if you don't want that one, right, then you go for the TCP traffic, because in TCP you will not use SSL port. Okay, so now under that also you can have global. So if you want global, you can have global also. If you don't want global, you can have regional also. So then that regional TCP, regional TCP falls under this one, this category in this diagram. So here also you can either preserve that particular IP address, or you don't want to preserve. If you don't want to preserve, then again you can use proxy, because it will terminate that. If you want to preserve the same IP address, you want via TCP traffic you want to go, but you want to keep the IP address also, then you go for the TCP, the normal one without the proxy, right? And since it's an external, then it's an external UDP or TCP traffic. Now another category is whatever other than TCP that you want, UDP, ICMP, SSH, whatever the traffic you want to route, that will be done via this external UDP TCP load balancer. Okay. Okay. But this will be again just regional. Okay, regional and external are two different things. Again, I'm keep on repeating, just don't confuse regional and external things together. Okay, so your TCP UDP will always be regional, but it can be external or internal both. Okay, now the other part is simple. The other part is very simple. If it is within the GCP that you are working, right? uh, okay, so within GCP, if you want to communicate, you don't have any external traffic coming in, then only support is for IPv4, and this will be internal. So internally also you can have HTTP, as we have seen within the region, right? So internal means this will be internal to GCP, internal to GCP, and this will be deployed at single region again. So it will be internal and regional HTTP traffic. Similarly for TCP also, TCP and UDP, you can use TCP and UDP internal load balancer. We have seen that the third one, right, on the load balancer page. That's the one. So, but this will only support IPv4. Any question? So this is not like one single unique solution will work for everyone. So this is again case by case basis. We'll have to understand. Like I have given you an example, right? For web application, you will go for HTTP. For network load balance, for the network packet level load balancing, if you want, you will either go for other ones. Now in other ones, you will have to either select TCP, either you have to select for SSL, you'll have to select UDP, depending upon what type of traffic that you are sending, request that you are sending, you will go for that particular one. Shabi, your LinkedIn link. So Shabi, I mean, as part of my NDA with Edureka, I cannot share. I mean, yeah, I mean, I can share later, but I cannot have any personal communications with you. It might have happened with Edureka that previously, that I think we are not authorized to send our mobile numbers or anything, and create other personal groups with my batch. Okay, that's the NDA with me and Edureka. So my personal things I cannot share, but LinkedIn I can share. But we cannot have any personal discussions apart from the Edureka thing. Okay, so and that's the NDA. That's why I'm just telling you, Shabby. Any other questions, guys? Sorry, I have taken 14 minutes past today, but I just wanted to conclude the networking today so that from tomorrow we will be actually tomorrow's topic will be on the storage services. We'll explore all the storage services that are available with GCP. Okay, so like all the way from Cloud SQL and your file store, Firestore, data store, right? Cloud storage, all those things we will see when to choose what, and we'll also see the demos on most of them. So that will be the agenda for tomorrow. Come prepared. Just read out some of the stuff on the storage services. It will make more sense. If you have any questions, just post now. I'll be happy to answer. But uh, I know this was very extensive class. We had 3 sessions on networking. As per my knowledge, even if you are going for any network level certification, also maybe 85% will be covered already in my teachings. Okay. But since this course is all about architect certification, so but I'm sure from architect certification perspective everything is covered. uh, the and ACE perspective also, cloud engineer perspective also, everything is covered. So yep, I tried my level best to cover all the networking concepts. But yeah, if you have any other topics to discuss, um, yeah, just you can put on the chat. Somebody wanted to unmute. Was it Shrey? If you want, I can unmute you, but let me wait for any questions if there are any. Just for the Shabby said just for the connection, not discussion right now. Might be in the future need something to ask. Okay. Um, Let me just check with the HR if they allow me. I'll surely share with you tomorrow or later. Shabby. Any other questions on the topic, guys? Um, any feedback? Was it bouncer went top of your head, or did you learn anything? I'm just curious to know whether it is making sense, or is there any changes in the teaching that you require. I'm just waiting for some feedback. Original diagrams in the rough notes. Okay. Okay, Siva. I can put original diagrams also. Yeah, that's a good input. I'll put original diagrams at the very last. Okay. So that you have a plain diagrams also. That's fine. Any other feedback on my teaching? If you want any feedback, I'm going too fast or anything like that. I'm not sure. I mean, whenever I teach something, I get questions, but when I ask for some questions, I don't get any responses. That's very unfortunate. I'm not saying, and then I sometimes I have got the feedback that I'm not interactive. So it's somehow I'm not getting responses. How can I be, interactive if I'm not getting responses? Too much of information to process. Yeah, I understand, Dia. I'm not sure about your experience, but looking at your questions, I feel your experience one, but Then for architect course, this is all these things are important. Networking is very important topic for the architect certification, because unlike for developers or engineers, architects need to understand how the networking, how the security and all those things, aspects of your infrastructure, right? So I'll have to cover these in these details. That's why it is more information that I'm trying to provide. Gana says will be helpful if you can show one example to perform assignment. Okay, so assignment, one example for assignments. I mean, let's do it this way, Gana. Today, I think I've already taken up around 20 minutes more. There are people from other regions also. It might be late for them. So let me check one of them. I never go for the assignments. It's all purely for you, and you need to tell me that you have some doubts or something like that. Not me, basically. It's for if there is a backend team, you can reach out to them. But yes, let me check one of the assignment. I'll show you how to approach. Okay, so we'll probably take it tomorrow, Gana, if that is fine with you, Gana. Feedback is very nice. Okay, thank you, Shiva. Too much of information to process. Diya, yeah, we already discussed on that. Will you cover ML and AI in this course? Not in depth. Okay, just conceptually we will see, but this is for architect certification, and there is no much scope on. You just need to understand these. There are these services. What are the services where you can write ML codes, where you can train your AI models and all those things. So like there are certain, I don't want to disclose this right now here itself, but like you have Python Jupyter notebooks and all. Similarly, you have similar managed GCP service also that we'll touch upon, but I'll not be writing the code and going in detail on that. Okay, Siva has another one. Once revisit the class, understanding the things clearly in the class, it's a bit confusing. Revisit the classes things, understand the clear. Okay, yeah, yeah, correct. That's what I've been telling you. You need to revisit all the rough notes, and if needed, try out these demos also, so that it will start making sense for you. Yeah, and if you stuck at something, I am always there. But if you don't want to wait for 5 more days, you can always Google, and you that way you can also ask me questions. It might happen that I also encounter some mistakes, or I also get to learn if there is any new things coming in, right? So yeah, it will be a mutual learning in that way, I would say. Are we going to see about anthos? No, nothing related to anthos also will not be covering, or anthos also. That's also not required. Okay, but we will be extensively working on Google Kubernetes Engine, Shabi. We'll be deploying containers in GK and everything. Containers. I'll be even starting from scratch on this containerization. I'll also share how a monolithic application evolved into containerized application and all those things. I'll try to cover as much as possible. Okay, I hope nothing else is coming up. Is anyone has any other question? Anyone wants to unmute himself or herself? I'm open for that as well. Otherwise, feel free to drop off. Shrey, okay. Let me just wait for any other questions. Just feel the feedback, guys. Just a reminder. Okay. So Shrey, let me unmute you. Sachin, thanks. Informative session. Thanks for that. Yep. Thanks for the words. Let me unmute you. Shrey. Yeah, I just unmuted you, Shrey. You can unmute yourself
Hi,
and
Ashwin.
then
Yeah, am I
finish, Shrey.
audible?
Yep, I can hear you.
Okay. So actually, my question was, for example, we were looking for the like we said, it can allocate VMs based on different in different regions, so based on the availability, or maybe so same kind of machine can cost $25 in somewhere in US, or $23 basically. I've seen that. And same machine will cost $28 in the Singapore or some other region, or Mumbai. I think in India it is costlier. I've seen that in than in the US.
Yep,
So
exactly.
and also and so now, so if it allocates more machine in India, and let's say it allocates 100 VM, I'm just giving a hypothetical example. So it
Mhm.
will, my bill will be more. And if it's like one or two, it doesn't make much difference. But if it's like multiple, it will cost. So can I tell them that it only should allocate in a specific region, or should only allocate the cheapest one? Is there a way to tell that
Yes.
with allocation? Okay.
So when you create a VM, you are talking about an individual VM or a MIG?
I think am I the management? Yeah, when it gets
Okay.
it can have a multiple VMs
Right,
also.
right. So when you create an MIG, it asks for a region, right? So basically, and see, now you when you think from an architect perspective, or from a business perspective, you don't really just look at the cost. This, for a big project, okay, if your project is spanning across the regions, you are catering a global public, right? A global end user base that you have, right? Then this particular difference that you have, right, maybe like $4, $5, right, for the same type, I'm telling you, right, if you change the region, it will be like some minor amount that will be different. But if you have that much of big requirement, then your, of course, your enterprise itself is big enough, right? So that difference will not be that too much that you are looking for, right? So, or you are assuming, so that difference, first of all, this is the first point, that this difference will not be too much for that level of enterprise, right? So if your company is too big, then only you need this kind of thing, right? Otherwise, if you have a certain user base, let's say you want to cater only US public, US end users, right? Then you can always select, when you create an MIG or you create a single VM also, you have an option to select the region. Then you select that particular region. If you are creating a single VM, a standalone VM, then you have a finer control as well, that you can only create a VM in a particular zone. Okay, so let's say you select Boston, then that VM will be created in Boston only. Even the same happens with MIG also. The You have selected a Boston region, then it will be created, that entire, all the VMs, there are 100 VMs or whatever you create, those will only be created in Boston. But then if you have a India person, a person sitting in India to hit your web application, he will still be able to get the response. It's not that the Boston machine will not respond. Okay, load balancer will take care of that. But in order to have reduced latency, you can have lesser machine. Let's say, let's say, take an example of Flipkart. Okay, so Flipkart is a, let's say, majorly being used by Indian public, right? But it doesn't mean that it is not accessible from US, right? So what Flipkart can do is, Flipkart can create a less number of VMs in US region, and more number of machines or VMs in India region, right? So you can have that kind of ratio also. And so that, based on the IP address, you can you know uh, cater the traffic from that particular region itself. So since you are expecting less people in US for Flipkart, then it will be served from that particular less number of region. And if it is a vice versa, right? So you can have less number of India region VMs to reduce your cost, right? So does that your answer your question? Does it make
Yes,
sense for you?
yeah, sure, sure. Yeah, I got it.
Right,
Thank you so much. And
right.
one more thing I've observed is that there's something called when they allocate this, when we see the regional map, right? It says low CO2, high CO2, like that it mentioned.
Hmm, hmm,
And
hmm,
where there's low
hmm.
CO2, I think the cost is less. Something like that. I have observed that. Is that the
Perfect.
understand?
Yeah, yeah, very good question. So basically, low CO2 is basically, so if you typically see the data centers, right? So these are large servers that we have. We are talking about buildings where we have the racks and we have a lot of servers and a lot of capacity, lot of CPU. So if you see that like that, we have so many big data center and they have a lot of CPU power. So these CPU powers need some cooling, just like the cooling that you have in your laptop, correct? So these needs a lot of electricity power. And what this CO2 emission is basically, these they need some cooling system. These data centers has a big cooling system to keep the CPU in under proper temperature. Okay, so this is just like at a very granular level, you can understand your laptop gets heated, right? Similarly, this data center also can produce a lot of heat. For that, to regulate the temperature, they need a lot of refrigeration, not refrigeration in the exact word, but some cooling power is required. And for that cooling power, like just like you understand a simple AC working, right? It emits CO2, the air conditioner at home. Similarly, this cooling generation also at data center will generate lot of CO2. But the cooling system that Google uses has entirely on the natural, what I can say, natural energy creation, right? What we say, like solar energy, right? Right, the natural resource for energy creation that has been used by Google Cloud, and that's why some of those data centers which shows low CO2 emission, that means they are using natural energy to create
Okay.
the cooling for that. That's the
Okay.
information about. Okay,
Okay.
so it's,
Because
yeah.
I think it's only
So
in the US. I think in India, I think it's as well as in Mumbai, it's in Delhi, but they are not on low CO2. I think they are on high CO2 at the
Mhm.
moment.
Correct, correct,
India.
correct, correct. So that's the, I mean, among all the public clouds, Google Cloud is the lowest CO2 emitting cloud. Okay, so it's called as there is a term.
Green
Not a
energy or green.
no, 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 not green. Yeah, green energy is the cause. I mean, what we are saying, low CO2.
Correct.
But I'm talking about there is something free to it. I'm not able to recall on top of my head. Emission free or something like that. Okay, so there is that keyword that is attached with the GCP cloud.
Ah, okay, okay, okay. Fine.
You will find
And
it on the
well,
Google if you search it. Yeah.
yeah, sure. Sure. Thanks. Thanks. Okay.
Um,
One last question regarding that. So I think you mentioned stateless and stateful one. So you mentioned that
mhm.
stateless would not have that much of a tracking. It's like stateful will be like more of a tracking. So does stateful cost more than stateless because stateless would have less sources in terms of
No,
tracking and more?
no. From the pricing perspective, no. It's just that if you want
Okay.
to keep a track of more metadata at the MIG level, then just go for this one, the
Hmm.
stateful. Else you go for
Right.
the stateless.
But the health
There
check
is
and
no
all
no,
health
even
check is available.
health check. Sorry, go ahead.
Sorry, health check is available in both these, right? In stateful or stateless both.
Yes. Since it is managed, both of them are managed. Health check is available in
Okay.
both of them.
So mandatory things are there in both, but only some optional elements if you want to have additional on
Yeah,
as a top up, they can have it in the state full.
correct.
Okay, got it. Sure. Thank you so much, Ajay. Thank you so much.
Okay, thank you, Shrey. Uh, any other question, guys? Anyone else want to talk? Let me just. I don't see any new questions though. One sec. Somehow I lost my. Somehow I lost my questions box also. Okay, I think I'm the last. I don't see any new questions, guys. So then I think we can conclude for the day. We close this. I think we still have 15 people. Okay, then I think we can conclude for the day. Thanks for joining the today's session. Tomorrow we'll be covering the storage services. and I'll attach these rough notes as well with clean diagrams as well. Okay, so I think, yeah, then we can conclude. Thanks for attending and see you tomorrow. Have a nice day. Bye.
Thanks, Arshil.